this session. It's been our pleasure to coordinate this event, and I wish you all a pleasant day. You may also follow us in this event through our DVCRI WebEx and also in YouTube. Ladies and gentlemen, before we begin, I would like to highlight a few important points for our event today. Please take a look at your chat box. In the chat box, you may find the program kit, which includes the guidelines for the WebEx meeting, program book, and also the virtual background. Be sure to complete the attendance form using the link provided in the chat box. Ladies and gentlemen, for your information, today is the second day of Symposium I-Bes 2022 for Biorefinery and Biotechnology session. This morning will be divided into two subsessions and ended with a forum where questions and answers will take place. All presenters are requested to stay on this WebEx platform until the end of the forum. If you have any questions about this symposium, please get in touch with us through the chat box. Ladies and gentlemen, this morning we are so delighted to have well-known expert as our session chair, Professor Dr. Lee Chiu Tin. Allow me to introduce her to all of you. Professor Dr. Lee Chiu Tin received her PhD in engineering from the University of Cambridge, UK in 2004. She currently serves as a professor in the School of Chemical and Energy Engineering, University of Technologi Malaysia, UTM. She has published over 170 international scientific papers and holds various editorial roles, including in the Journal of Clean Production, Energy and Chemical Engineering Transaction. Professor Dr. Lee Chiu Tin was the former Director of Global Education at UTM from 2008 to 2016 and visiting scholar at the University of Polytechnica Madrid in 2015 and Shanghai Jiao Tong University in 2019. She is also the co-chair or director of the International Conference on Low Carbon in Asia and run international summer programs to promote sustainability. Registered as a chartered engineer registered as a chartered engineer of Institution of Chemical Engineers United Kingdom and a member of the Institution of Engineers Malaysia. Prof. Lee is very passionate about promoting sustainable organic waste management through the 3R campaign, biomass to energy and composting. Hi, Prof. Lee. How are you today?
Yeah, good. Thank you, Julaiha, for your comprehensive introductions. Thank you.
Thank you. Thank you for joining us, Prof. Lee.
Yeah.
Okay, ladies and gentlemen, without further ado, I will invite Professor Dr. Lee Chiu Tin. Now the floor is in your hands.
Thank you, Julaiha. Okay, so it is my great pleasure to chair this session 3, day 2 on I-Bes 2022. When I was a global education director, I have visited Universitas Air langga. So this university is quite familiar in my heart, and I'm very pleased to see these sessions strengthen the collaboration between both universities. Okay, so for today, as Julaiha mentioned just now, we will have for the first session 4 speakers. Firstly, we will welcome Professor Dr. Rosli Mat Ilyas, who currently serves as the Deputy Vice Chancellor for Research and Innovations, and he will be talking about transdisciplinary research in biorefinery. And later on, we will follow by plenary speaker, Dr. Ali Rohman, and invited speakers 1, Dr. Zanaria Hashim, and invited speaker 3, Dr. Fedian Lucidi. Okay, so all of you, I have seen you are ready in these sessions. And without further ado, I would like to welcome Professor Rosli to deliver the first keynote. May I remind you, if you have any questions, please leave your question in the chat box, and we will leave until around 10:30 for a forum session where we will have more discussion on the 4 interesting topics related to biotechnology and biorefinery. Okay, so let us now welcome Professor Rosli's keynotes. No sound. Can you check the sound? Okay. Please share the sound. Yeah. Okay.
We had shared the sound, but just wait, probably for the
Yes.
technical problem.
It's okay. I can maybe introduce a little bit. Today, Professor Rosalie will share about the major conversion process of biomass into bioenergy and bioproducts, which will involve multiple and interdisciplinary research collaboration, which are very crucial factors to ensure the successful and implementations of biorefinery transformation. Okay, so let us now listen to his talk. Is it okay now?
Okay, Prof, we try to play it now.
Yeah, okay, let's try.
Oh, still cannot hear properly.
Yeah, still cannot hear.
Okay, maybe I will unshare again and I reshare again. Sorry for this inconvenience.
Yeah. Okay. So maybe I can go through a little bit on the upcoming talks. Okay. After Professor Rosalie's talk, we will listen to the plenary speaker. Yeah, Dr. Ali Rahman. I can see that you are already in the participant. Already come to the studio. You will be talking on hemicellulosic enzyme research in proteomics lab from Biomi, yeah, lab in Universitas Air. And then Dr. Zanaria Hashim will be talking on unraveling xylem phenotypes and quality attributes using metabolomics and multivariant techniques. And lastly, but not least, yeah, for the first session, invited speakers three, Dr. Fedian Losidi will talk on quantum mechanical approach to understand biological processes. Okay, so all four topics features the latest trend on biorefinery. I'm sure every one of us are looking forward to the talk. Okay. Okay, let us now try again. Uh, Still cannot. Did you share optimize for audio? You have to share. Uh,
Still cannot hear properly because
I think can you paste this video in the email? Maybe I can try to share from my desk. Is it okay?
I try again.
Or
Is it okay?
yeah, you can try again. But you know, under share, you have to share optimize for audio. Do you know?
Okay.
During the share, there is a function. You cannot simply just share. You must share, optimize for audio and audio.
Yeah. Okay.
Have you tried that function in WebEx?
Probably I wait.
Yeah. Or may I suggest maybe, do you want to try email to me? Sorry.
low energy data transmission. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and a very good morning.
Lee, can you hear?
Yes, now okay. Thank you.
Say thanks to the organizing.
So we're going to repeat again.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and a very good morning. I would like to congratulate and also say thanks to the organizing committee of I-Bes 2022 between Universiti Teknologi Malaysia and also Universiti Air Langga for inviting me to give this keynote speech. And the title of my speech today is about interdisciplinary research in biorefinery. Well, currently we are facing a lot of problems in the world, especially that related to our sustainability and cause of environmental disasters. For example, due to our industrial waste that cause air pollution, endangered wildlife, water pollution, and also solid and landfill that is actually a big problem to our community and country. So if you look at in terms of waste, it is increasing each year, and by 2050, it's about 3.4 billion tons of waste will be generated throughout the world, and this is not a good thing that we have to face for our life. So this cause very challenging to the global system. Among the things that have been identified as global challenges by the World Economic Forum are agriculture and food security, our economic growth and social inclusion, things that related to environments and natural resources security, feature of our global financial system, our investment and in terms of our infrastructures, international trade and investment, and also gender parity. And among the common things that that is discussed throughout the world related to the global challenges is about the environment. We need to have a sustainable and safe environment and clean environment for our future generation. Facing problem in terms of energy, water, and also food security. And eventually all this will affect the societal well-being of the nation and the country. If we go back in terms of industrials, for example, biotechnology or chemical industry, the chemical production globally is increasing. You can see from this slide, it is increasing quite significantly compared to the increasing of the global population. However, people start realizing about the clean environment, about the safety, and this is where the green chemical market globally is increasing. And by 2025, about 15% of global chemical sales will be bio-based. So what are the next big technology trend that can solve or expected to solve a lot of problems in the world? Because we need new innovation in order to be sustainable. One is about biological transformation. This is something that the European country thought will be the next big technology trend in the future. Biological transformation involves the use of biological technology, engineering, and also information technology that can come together to solve problems. Smart materials, for example, producing more sustainable products, enable new materials properties, recycling, new renewable plastics, and even a smart nanomaterial. We are expected to face low energy data transmission technology that can decrease energy requirement for IoT among products. Smart DAS, coherent optics, power to X. This is where new energy system turn natural resources of energy into heat, fuel, or chemical products. For example, hydrogen, carbon capture and storage. And finally, to explore a marine technology. Why? There is a lot of resources that can be explored for the benefit of human beings under the sea, for example. So, what is sustainability? The world needs green technology. The world needs sustainability and green technology. So sustainability is a path forward that allows humanity to meet current environmental and human health, economic and societal needs without compromising the progress and success of future generations. There are basically three elements of green technology: a system that uses innovative methods to create environmental friendly products, uses natural renewable resources that never depletes, changes waste and production pattern to not harm the planet. So there are some elements of green chemistry or green technology. There are about 12 principles that need to be followed. Among them are to prevent waste, to use safe solvent, to reduce product toxicity, renewable resources, which is related to biorefinery especially, to omit derivatization in process monitoring, use catalysts, avoid the high temperature, prevent accidents, design for degradation, and even about atom economy. So, in order to proceed, in order to use green chemistry or green technology, there are basically three strategies. This either you use a physical methods, a chemical method, or a biological approaches. For example, in the physical methods, there are methods using ball milling, microwave irradiation, ultrasound synthesis, hydrothermal synthesis, and even photocatalysis. And chemicals involved, for example, the use of supercritical green solvent, supercritical water, and even a metal oxide nanoparticle. However, in this context, a more non-toxic, stable, environmental friendly is the biological approach. In this case, we can use enzymes from plants or from the microorganism, and even we can use the microorganism itself as an agent for the conversion of any biomass, for example, into bioproducts. So people are talking about bioeconomy. So what is the prospect of this bioeconomy? The concept of bio-based economy goes beyond the traditional definition of biotechnology. And we are talking about bio-based economy. It focuses on the biological tools and products from renewable resources to create wealth and sustainability. And one of the key components of the bio-based economy is industrial biotechnology. When we are talking about industrial biotechnology, cannot run away from the biorefinery processes. So from biofuel to enzymes to bioplastic, product and processes of industrial biotechnology are going to be the building blocks of a new economy. In order to solve the global challenges, worlds have come out with the sustainable developmental goal approaches. This SDG can be used as indicator to monitor the progress toward a sustainable bioeconomy. There are linkages between the bioeconomy principle and sustainable developmental goal. For example, if you look at principle 5, it is about the sustainable bioeconomy should rely on improved efficiency in the use of resources and biomass. And I believe this is closely related to biorefinery. Principle 5 contribute to SDG number 6, number 7, number 8, number 11, and even number 12. So this is how you can see the link between the bioeconomy principles and sustainable developmental goals. So what are the elements of bioeconomy that is expected by 2030? This related to renewable biomass. the integration of biotechnology application across sectors. This is where the interdisciplinary approach is very important. Advanced knowledge of genes and complete cell process. And for example, in this case, is the development of microbial cell factory. Microbial cell factory is a microorganism that have been designed, improved, strained, that is used to produce bioproducts such as biofuels, biomaterials, biocatalysts used in biorefinery for the conversion of natural resources such as biomass into uh, valuable bioproducts such as succinic acid. So now agriculture and forest industries has generated about 40 million tons of lignocellulosic. And this biomass is distributed on Earth. I'm sure Malaysia and Indonesia have a lot of biomass resources, such as from the palm oil industry, rubber, even an industrial agriculture plant such as Kenaf that can be used as a resources to replace fossil fuel for the production of valuable products in industry. So biorefinery is one of the most important approach or strategy to convert all this biomass into this valuable byproduct. Biorefinery opens the opportunities for reuse, recycle, remanufacture, which is known as the circular bioeconomy. And you need various different technology in the biorefinery process, such as the biocatalytic conversion by using either the microorganism or the enzymes. And you also need a fermentation technology, even the separation technology, in order to come up with the byproducts such as biofuels, bioproduct like succinic acid, and even heat and power for generating energy and electricity. So biorefinery permits the full integrated use of biomass that generated into a spectrum of bio-based product and bioenergy. From the biomass, for example, can separate it into a smaller component such as lignin, hemicellulose, cellulose, and even from starch. This biomass is a source of sugars, where the sugars is the main building blocks for the production of the chemical product that eventually used to produce uh, commercial applications such as in cosmetic, pharmaceutical, uh, food industry, even the automotive industry. Now, to convert a lignocellulosic biomass into uh, valuable bioproducts, it needs a process of valorization. So there are basically a few strategies where valorization pathway can take place to turn lignocellulosic biomass into the bioproduct, which is the thermochemical conversion, the chemical conversion, biological conversion, and finally the mechanical conversion. And in order for a sustainable biorefinery strategies, other elements need to be taken to consideration. It is not only about the technicality. We are talking about the technicality. We need to optimize processing for biorefineries, to research development and innovation. For example, to operate at right scales, improve cost effectiveness of the treatment, improve selectivity of processes, free inaccessible sugar, valorize lignin. But there are also three other elements that need to be taken into consideration. The environmental aspect. How can we foster a supply of sustainable biomass feedstock to both existing and new value chains? The responsible use of land to minimal soil depletion and to balance CHG emission, carbon gas emission. What about the economical aspect? Create and accelerate market uptake of bio-based product and application. We need to minimize food versus feed conflict when we use this biomass. And finally, about the societal aspect. This is where we need to create policy support to improve livelihood, rural areas, and enable individuals. Collaboration with stakeholders is very important. So in order to have a sustainable biorefinery strategy, at least 4 elements need to be taken into account, especially in our case for the scientists and for researchers is about the technicality. So if we are talking about biological approach in biorefinery, so the bioconversion can go through either the whole cell biocatalyst, which is the cell itself, or through the enzymatic conversion. Okay, and microorganisms, for example, play an important role in industrial bioprocess, especially in the biorefinery process. So I'll give you one example. For example, in terms of the production of xylitol, previously people are using a chemical reduction approach from D-xylose into D-xylitol, but this method use high pressure and high temperature, which is not good for the environment. So by manipulating the microorganism pathway, improving the microorganism strain, scientists managed to come up with a few type of strain that can produce xylitol directly from xylose by implanting new genes, for example, xylose reductase. A new strain of microbe that can use other sources other than xylose, for example, arabinose, have been used to produce xylitol. And in my lab, we also have produced microbial strain that can use glucose for the production of xylose. So we have manipulated this microorganism, in our case the E. coli, for example, that can convert starch into glucose that can be taken up by the microorganism to produce xylitol. We have also come up with a new strain of E. coli that can use different type of sugar, for example, xylose, arabinose, and D-glucose that can be used together to produce xylitol. So how we did this or produce this strain of E. coli? You need an integrated knowledge of genomics, integrated knowledge of bioinformatics, and metabolic engineering in order to implant or to delete certain pathway so that the cells can not only use xylose, but also use other sources for the production of xylitol as seen in this figure. Okay, so in order to develop the whole cell biocatalyst, in order to design the whole cell biocatalyst, there are a few things that need to be taken care of. In terms of the substrate uptake, the output of the product out of the cells, we need to control the rate limiting step, to balance the pathway, to delete the competing pathway in order for the cell to be optimized. And in order to do this, different knowledge need or different kind of research need to be imposed. For example, we need to know about the genomics of the microbe. In order to manipulate the genome, we need to have this biocomputing approach. And of course, at the end of the day, we hope to come up with the best strain that can produce high value product. The knowledge of proteomics is very crucial. Why? Because from the knowledge of proteomics, for example, in identifying what are the proteins that are needed to improve the strain, and what are the protein or the post-translational modification that need to be manipulated or to improve in order to get high yield of products for the new strain that have been developed for biorefinery. So in a cell factory development, for example, in biorefinery, an integrated approach need to be taken into account. Now, at the end of the day, the cell will be put into a big fermenter. fermentation process or large-scale production process will be carried out. So this is where an integrated research, interdisciplinary knowledge need to be adopted, from genomics up to the process engineering and separation technology. Right? As you can see from this slide, you need the genome sequence to annotate the genome and to do the analysis. You need biocomputing, and when you want to study the physiology, the transcriptome, or the metabolomes, and even the flux analysis of this cell production, you need to put it into a fermenter. The knowledge of bioprocessing, it is critical to come out at the end of the day with the best strain available. So this is, for example, one strategy that been used in biorefinery, which is the consolidated bioprocessing, where in this CBP, a process, an enzyme production, biomass hydrolysis, and monosaccharide fermentation for production are combined into a single step. And in order to do this, an integrated and interdisciplinary research need to be conducted first. So there are different areas for viable and sustainable biorefinery: the life sciences, biology, the molecular biology, the proteomics, the physical science and engineering, the mass transfer aspect, the fermentation processes, the control system, and in fact, the social science and humanity, to look into the ethical aspect of developing the new strain, look into the impact into the society. So these are the combination of knowledge that actually can bring forward and the successful of biorefinery for our next generation, right? So this is one of the example from where a company called Unicore developed its production line from a renewable feedstock into microbial strain development, large-scale fermentation, purification for the bioaspirin, and at the end of the day, they get this polymer-grade bioaspirin product. And this cannot be achieved if it is only due to a single disciplinary research or technology. So an integrated bio-based process for production of bioaspirin is important. We need R&D in order to develop innovation and to solve the global challenges that I have mentioned just now. So this is where in order to have a successful innovation, there are three primary ingredients: new knowledge, capable people, and environment that promotes innovation and entrepreneurship. So this is where the interdisciplinary research is very important. It requires more commitment to go beyond disciplinary boundaries. If we combine a disciplinary research, for example, biology, chemistry, and physics, it can become an interdisciplinary that merge, convert into a new area. Right? The interdisciplinary research involves the search of a common ground for different disciplinary and amalgamation or synthesize into something new. But of course, there are challenges, for example, for the young researcher in terms of innovation, is in career, even not many grants are sometimes provided for interdisciplinary research. So why we need this interdisciplinary research, especially in biorefinery? Because the problem that we are facing to solve global challenges are too complex to be effectively addressed by a single discipline. Climate changes, natural sciences and engineering, plus social sciences. In biorefinery itself, you need different stages, different processes in order to convert or to change the raw biomass into valuable bioproduct. So there are, for example, few key technological building blocks in biorefinery. For example, microbial genomics and bioinformatics, metabolic engineering and modeling, innovative downstream processing, which relies a lot on engineering technicality, biocatalyst, fermentation science engineering, biocatalyst function optimization, and in fact, the study on the novel enzyme and microorganism itself. So before I stop, I would like to quote Spanish philosopher that say about if we only focus on disciplinary research, a possible side effect of the ever-growing specialization is the narrowing of intellectual horizons and creation of what is called as learned ingrami. That is, people who are expert in their own particular area but not capable to see beyond. We need interdisciplinary research to see beyond the current situation, especially for biorefinery, to solve the problems or the global challenges. Thank you very much.
Thank you to Professor Rosalie for the very insightful updates on the multidisciplinary research focusing on biorefinery. We can see how intensive and how many scopes of the study that are needed to realize this scenario. Yeah. So at around 10:30, when we have our forum, we could have more discussions about the biorefinery development in Indonesia as well as in Malaysia. Yeah, especially we can also talk about the Indonesia's goal to produce bio-based palm oil biofuel produced from the palm oil. Yeah, so this is a very interesting move, and we can discuss how viable is this process for the future. Okay, and I think the recent ban of the palm oil export to the global market has also impacted the or cooking oil and making it a kiosk. Yeah. Okay. So I think this is a very interesting topics that we can have more discussion during the forum. Without further ado, I would like to now invite the next plenary speakers, Dr. Ali Rothman on the topic hemicellulolitic enzymes research in proteomics lab from Universitas Air Langga. Okay, Dr. Ali, would you like to begin?
Yes, okay. Can I share my screen?
Yes, please. Yeah, there's a button share on the right hand side. Can you see?
Okay.
Yeah. In UTM we use WebEx.
Yeah, we used to, let's say, sorry.
So, and may I remind everyone again, please leave your questions in the chat box, yeah, to facilitate our discussion during the forum.
Oh. It is, I could not share my screen.
Have you
Yeah, I have. Okay. Yeah,
click the share button?
Okay. Okay. I need to leave the meeting and
Dr. Ali, are you there?
to leave because my computer need to
Restart. Okay.
restart,
Yeah. Okay. So we just wait for a while. Okay, no problem.
Dr. Ali, we will share your screen, your presentation from my computer.
Uh,
Is it okay?
so I already shared my screen. You can
Oh,
see my
okay.
screen now, yeah? Okay.
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 All right.
Thank you very much. So, Assalamualaikum warahmatullahi wabarakatuh. Thank you very much, Professor Lee, for allowing me to do this presentation. And yeah, also thanks for Dr. Zuleha for helping. Currently, I'm the coordinator of the lab proteomic. The lab proteomic is the part of the research center for biomolecular engineering. So we call it is Biomi. And yeah, the lab is already start up around 4 or 3 years ago by Professor Newman, yeah, who is very busy with as vice rector in Universitas Air Langga. So Professor Newman asked me to coordinate the research in the lab. So in this good opportunity, I would like to introduce the proteomic lab to all of you. So we in proteomic lab do research in the area of the industrial enzyme, particularly in the hemicellulolitic enzyme. So hemicellulolitic is the enzyme that take an important role in degradation of plant biomass. Professor Rusdi already pointed out several aspects of this kind of biomass degradation. Yeah, so yeah, I will continue the discussion with what we are doing in a proteomic lab. So let's start with the plant biomass. Yeah, Professor Rosley already mentioned that we have waste everywhere. Yeah? So this is several example of biomass that are familiar with us. So plant biomass like grasses and corn accessories, palm oil waste, rice straw, wood, and etc. Are usually found as a residue in agricultural and forestry industries. Then this kind of resource are renewable, so they are sustainably available in a large amount. So I mean that we can find this material easily. So actually, this kind of material have high potential to be converted into a variety of useful product. For example, wood is the traditional raw material for making paper. So it is yeah, very important for our culture. Then the plant biomass also have a high content of the monosaccharide cellulose. Yeah, this kind of monosaccharide already discussed long by Professor by Professor Rosley, and this monosaccharide can be converted into xylitol, which is the low-calorie sweetener. And other example is the prebiotic. Yeah, so in the food supplement, The prebiotic is prepared with using silo oligosaccharide as an active ingredient. Again, this silo oligosaccharide can also be produced from biomass. And importantly, the biomass is can be used as a almost unlimited resource for biofuel production. The second generation of biofuel, which use non-food carbohydrate as raw material. So we can see here the potential of the plant biomass. So yeah, it is known that the main component of the plant biomass are consisted of the polysaccharide cellulose and hemicellulose, and also the polyphenolic polymer lignin. Yeah? And this component interact to each other, interact extensively to each other to make compact and strong structure. So basically, the chemical component of biomass are polysaccharide, carbohydrate, yeah, with the complex structure. To convert the complex polysaccharide into usable product, then they have to be modified or degraded by any means. So it is basically possible to degrade the biomass by using chemicals, yeah. But with this way requires a lot of harsh chemical that have a bad impact for environment. Then it is not preferred to degrade the biomass by using chemical, because it will increase environmental pollution. Alternatively, we can use enzyme. Yeah? So by using enzyme as chemical replacement, then we can reduce the potential pollution from the chemical, and we get green biomass industries. But however, because the nature of the carbohydrates are very complex, then to degrade this kind of material with enzyme, we need a long list of the enzyme. So lignin, for example, can be degraded by ligninolytic enzyme. Yeah, there are many type of this enzyme family that can be used to degrade lignin, like oxidase, peroxidase, and for example, lactase. Yeah? And hemicellulose, usually degraded by enzyme called hemicellulolitic, and this enzyme include silanolytic, namely silanase, beta silosidase, alpha L-arabinofuranosидase, acyl silanesterase, etc. And for degrading, for modifying this polysaccharide, the cellulose, at least we need this kind of enzyme, including endoglucanase, silobiohydrolase, and lytic polysaccharide monooxygenase. So in this case, we need many many kind of enzyme to process the complex carbohydrate. We in proteomic lab do research in this enzyme list. Yeah. So we do this research by many people in the proteomic lab. So we do this enzyme particularly from thermophilic bacteria. So we find the enzyme from thermophilic bacteria. For example, we collect sample from hot spring in West Java, and from the sample we managed to isolate this Geobacillus thermoleophorans. The bacterium is thermophilic. It grows optimally at 50 around 50 degrees, and from this bacterium we managed to clone sialytic genes, including one gene that encode sialanase, and two beta-sialosidase, beta-sialosidase 43A and 43B, and one gene encode for the enzyme alpha arabinofuranositase. So we already produced this enzyme recombinantly in E. coli, and this enzyme we extensively studied this enzyme. Another example is the sample from hot spring in East Java. So this hot spring is in Pacet, close to Surabaya, and relatively close. Yeah. And from this sample, we managed to isolate Bacillus thermophilic Bacillus species. Interestingly, this Bacillus species, in addition to have hemicellulitic activities, the bacterium also show good activity as lactase. So we also do cloning and characterize this enzyme. And to find a new enzyme, new hemicellulitic enzyme, we do metagenomic study from sample that are collected from mangrove environment, from peatland, hot spring, and also from several exotic environment. So we hope that from this metagenomic study, we can find new enzymes that are suitable for industry. Yeah, we already find an enzyme, cellulase, which is highly salt tolerant from this study. And to systematically study the thermal properties of arabinofuranositase, we exploit the bioinformatic database to find the enzyme, the arabinofuranositase, several arabinofuranositase from several bacteria that are predicted to have different thermal properties. And by this data, we do lab work to relate the thermal properties of the enzyme with their structure. So we believe that the properties, including thermal properties of the enzyme, are closely related to the three-dimensional structure of the protein. So we we also use this technique to learn about the hemicytolytic enzymes. And to improve the enzyme performance, we do protein engineering, especially for this enzyme from psychrophilic enzyme, mesophilic enzyme, etc. And we to confirm about the structure and thermal relation, then we do some mutakinesis to change the psychrophile enzyme into mesophile, etc. Okay, and the question is what we do with the enzyme. So yeah, usually we do cloning, the kin of the hemicytolytic enzyme, and then do purification as usual. And we also subsequently we do protein characterization, like activities determination, substrate preference, inhibition, kinetic studies, etc. And we also do bioinformatics approach to explain the physicochemical of a particular enzyme. In this, for example, in this report, we apply the approach to explain a cellulose enzyme. And then, yeah, this is important for us. So to get more insight into the properties of the enzyme, then we do structural study by X-ray protein crystallography. So, for example, in this report, we describe the structure complex of beta cellulosides with its inhibitor, and with the structure, we can explain which residues are responsible for the inhibition. Okay, and as I mentioned before, to improve the enzyme performance, then we also do protein engineering. For example, here we enhance the activity of lattice by fusing the catalytic domain of this enzyme with a carbohydrate binding module. So by combining these two enzymes in one molecule, then we have the lattice activity that was higher than the wild type. Yeah, because the enzyme has now, yeah, the new enzyme has a capability to bind the substrate more strongly. And yeah, that was about the, yeah, let's say science, yeah, but we also do research to apply this enzyme for application in industries. In this paper, we describe about lignocellulose cocktail preparation in the lab, and apply the cocktail for the inking of the recycled paper. We also do yeah, similar thing with lacase from, yeah, from fungi that was isolated from palm oil waste, and the enzyme is applied to yeah, modify the agricultural waste. And yeah, so we have just set up a fermenter for bacterial cultivation in a pilot scale. Yeah, so this this fermenter is intended as a teaching industry. So we would like to relate what we get from the research to industry. Then we try to produce the enzyme in higher scale. And yeah, I think that was the introduction about the Proteomic Lab at the Biomi Universitas Air Langga. And these are people that involved in the lab. So we have here Professor Nyoman, Tripus Paningsih, and this is me, and several team. So we have a family photo here about our team. So I think that was, and thank you very much, especially for the organizer to arrange this faithful silaturahmi conference. And also thank you very much for all of you for kind attention.
Thank you, Dr. Ali, for your very interesting sharing on where you found all your enzymes to degrade cellulose and hemicellulose. Okay.
Yeah.
I do post. I do have a questions that I have posted in the chat that we can have more discussion later on during the forum. Okay.
Thank you very
Because
much.
because I saw you focus a lot on the enzymes, different type of enzyme from different strains of microorganisms. My question is related to how economical feasible is it for the production of enzyme, especially we know enzyme extractions and purifications are quite expensive. How do you think that maybe if we use the whole microbe can be more viable, especially when we talk about waste treatment, because the product is not so much value added. Yeah, it's just and the scale is very big, and the quantity you need for the enzyme, the amount of the enzyme that you need is quite large. Okay, so how do you address the challenges for product formulations when come to different types of applications? Whether you prefer to formulate the product as an enzyme or as a microbe. Okay, so later on we can discuss about this. Yeah, thank you. Okay.
Nice. Thank you very much.
Yeah. Okay. So next I would like. Thank you. Yeah. Thank you. Okay.
Thank you very much. Yeah. So I will stop my screen.
Yes.
To stop it.
Yeah, you can stop sharing. Okay. And I would like to invite.
Thank you very much.
Okay, you can stop sharing. Thank you.
Yeah.
Okay. Okay, so next I would like to invite the next speaker, Dr. Zanaria Hashim. Okay, the title is Unraveling Silent Phenotypes and Quality Attributes Using Metabolomics and Multivariate Techniques. Yeah? Dr. Zanaria is a lecturer from the School of Chemical and Energy Engineering, UTM. Okay, so Dr. Zanaria, the floor is yours.
Okay, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning. Thank you, Professor Lee, for your kind introduction. Okay, so my name is Zanaria Hashim, and I'm from the School of Chemical and Energy Engineering, Faculty of Engineering, Universiti Teknologi Malaysia, UTM. I'm also currently the head of Food and Biomaterial Engineering Research Group, or FOBEC, in UTM. So today I'm very glad to be sharing with you my research. Okay, and the title of my presentation today is Unraveling Silent Phenotypes and Quality Attributes Using Metabolomics and Multivariate Techniques. So first, let me just give some overview of metabolomics. So metabolomics is an interdisciplinary research that uses the knowledge of biosciences, analytical chemistry, and informatics. And this diagram here shows you a typical workflow for metabolomics experiment. Okay, so we start by having our samples. It can be samples from animal cells or plant cells. Okay, and then the sample will go preparation steps, okay, and also the extraction of metabolites. So depending on what metabolites that we want to observe, the extraction method will differ. Okay, and then we will proceed to the next step, which is the instrument analysis. And in metabolomics, we typically use high throughput instruments such as the LCMS, GCMS, FTIR, or the NMR. And then after that, we go to the data analysis, where you have your raw data, and then you will have to do some pre-processing and then use the software to get some data visualization and interpretation of your data set. And finally, we can use that information from the data set to gain some information on the biological phenomena in terms of the metabolites expressed or the metabolic pathway. Okay, and this is a more detailed explanation on the data analysis workflow in metabolomics experiment. Because in metabolomics, we normally get a very large data set. So if we don't process the data correctly, we may get different or false interpretation of the data. Okay, so before we can actually use the data that we get from the LCMS or the GCMS, we need to do some data pre-processing, such as the denoising, baseline correction, peak detection, and so on. And then after that, we get the data metrics that we can use in the multivariate data analysis. Okay. So what is multivariate data analysis? It is a statistical analysis of data collected on more than one response or variable. So, for example, when you have many responses, say in this case for the metabolomics analysis, typically we have the responses on the types of metabolites. Okay, so the responses need to be analyzed simultaneously, and the variables may be correlated with each other. So it is more complex than univariate or the single variant analysis. And this is the basic statistical analysis for data mining in metabolomics. Okay, so I'm showing you here some examples of multivariate data. Okay, for example, we can have data set on students with their exam scores in a single course. Or you can have the data set of students with their grades in several subjects or courses. And in this case, we have the various responses or variants. So it is called as the multivariate data. Okay, and then next is the different types of multivariate data analysis. Okay, we can categorize the multivariate analysis according to our purpose of doing the analysis. Okay, so first one is the exploratory data analysis, also called as the data mining or the unsupervised data analysis. This is normally when we don't have a specific information, or we don't have like a we don't really know what we are looking for, but we want to get the overall insights, or what we want to get the overall idea of the samples. Okay, so example of this exploratory data analysis is the PCA, or the principal component analysis, and the hierarchical clustering. Next is the regression analysis, which basically when we want to get prediction models, we want to simplify the multivariance into a single X to Y relationship. And an example of this analysis is the PLS, or the partial least square analysis. And then we can also have classification or the discrimination analysis. This is when we have predetermined classes or bias. Let's say we want to separate the control strain with other strains, or the genetically modified strains or treatment strains. Okay, so we can use this kind of analysis. And examples would be the PLSDA, the partially square discriminant analysis, or the OPLSDA, which I will show some example later in this presentation. So the purpose of MVA is, first of all, we want to have to get data reduction or structural simplification, because typically when we get spectral data, it's a huge data set, and we want to reduce the data to only those variables that are meaningful or that give us some information related to our samples. And then because we also want to do sorting or grouping, and also to see the relationship among variables. Okay, this is just to introduce you with one of the platform or software that we can use for the multivariate analysis. And I particularly introduced this one because it's a free web-based MVA platform. So you can just type MetaboAnalyst and it will bring you to this website. And then you can basically upload your data and do the multivariate analysis on this website. Okay. Okay, so going back to the metabolomics and multivariate analysis, the applications can be divided into these 4 categories. The first one is metabolite profiling or cataloging, especially when we have, for example, new strains. We want to find out as many metabolites as possible. And then it can be also related to biomarker search. Okay. Let's say if we are studying about the disease and we want to know what exactly caused that disease or what are the metabolites that are involved in that disease, okay? And then also pathway mapping and also quality assessment, which I will also describe in more details later. Okay, going back to my title for the presentation, which is related to silent phenotypes. So one of the advantages of metabolomics is that we can actually study silent phenotypes. Okay, so when we mention about silent phenotypes, most of the time we are referring to silent mutation, which are mutations in DNA that do not have an observable effect on the organism's phenotype. Okay, for example, when we delete a certain gene in the cell, or in a microbe, for example, but we do not see any effect on the phenotype, such as the growth rate or the tolerance against, certain types of stress. So this can be considered as silent phenotypes. So there is no observable changes in the apparent physical characteristics. Okay, for example, when we see the same growth rate for microbe, the same weight or density or color for the samples. So in this presentation, I would like to show you some examples. These are actually what I have done in the past to show or to demonstrate the use of metabolomics and multivariate data analysis in finding the differences among samples, and also how it can be used to uncover silent phenotypes in microbes or other samples. So in the first example, in this study, we do the metabolite profiling for single gene deleted yeast Saccharomyces cerevisiae strains with less than 20% difference in growth rate. So in other words, you cannot really see the difference in terms of the growth rate of the strains, although we did delete the gene. Yeah? So we did the metabolite profiling using LCMS and GCMS, and then we do this data analysis, and we use a hierarchical clustering, or the HCA. So we can see the differences in terms of the so the colors here indicate the different concentration of the metabolites in the strain. So we can clearly see that yes, the strains may not be different in terms of their growth rate, but you can see the difference in terms of their metabolic profile. And then when we look at some of the clusters formed from the HCA, we can see that the clusters are composed of strains that has some similarities, and we can actually group those strains into different groups that share same, possible functions. For example, this group here, which shares this increased metabolites of citrate, trehalose, succinate, aminoadipic acid, and these cells may be, these genes may be related to the inositol and phospholipid regulation. Okay. Another example here is the use of metabolomics and multivariate approach in the quality attributes of cooking oils. So in this experiment, we use palm oils as our sample, and we fry the palm oils for, we use it for frying French fries repeatedly for 10 cycles. Okay, and this is the photo of the fried oils. Okay, after 10 cycles, so we can see here that there is no apparent change in terms of the color, for example. And indeed, when we check the color intensity, there is not much difference among the samples. And then also in terms of the specific gravity, basically we cannot see much changes. Okay, but when we analyze the samples using FTIR, and then we use the principal component analysis in the MVA, we can see that the fresh oil can actually be separated from the used oils. Okay, and also we found the wavelength or the frequency from the FTIR that shows that actually contributes to the differences between the fresh and used oils. So from there, further we try to correlate this wavelength found from the FTIR with two types of conventional oil parameter, which are the peroxide value PV or the conjugated dye-in value CDV. Yeah, so these two parameters are used conventionally to determine oil quality, and in our study we wanted to try to replace these conventional methods with FTIR, which is a more environmental friendly, because we don't need to use any solvents, or and it's a very fast method. So our initial intention was to replace this conventional method with a more environmental friendly method. Yeah, so we do find a very good correlation. For example, here for the PV, we correlated the PV result of PV and also the peak intensities from these two wavelengths, and we find a very good correlation with R squared value around 0.9. Okay, and same goes also with the CDV. So using this multivariate analysis, we can find this model, linear model, that actually that can connects between the CDV or the PV value with the FTIR peaks. Another example here is another experiment using yeast, Saccharomyces cerevisiae. So in this case, we cultured the cells under different stress conditions, but the stress conditions are very mild, that there is no apparent effect to the growth rate. Okay, so here we tested on three types of stress, which are the ethanol 1%, and then salt, sodium chloride 0.2 molar, and the sorbitol 0.8 molar. And after we did the multivariate analysis, it's very interesting to see that the ethanol stress group are clustered together with the control, whereas the salt group and the sorbitol group are separated much further away. And from the PCA analysis also, we can pinpoint the metabolites that are responsible for the separation. So by doing this kind of experiment, we can actually gain some insights on the stress mechanism for the strain, and probably from there we can identify the metabolites and also the pathways that are responsible or might be that are important for the stress mechanism. Okay, this is also related to the stress. Yeah, in yeast, we try to see whether the strains are ethanol sensitive or ethanol tolerant. Especially, this is especially important when we want to design a strain that is tolerant to high ethanol concentration. Probably when we want to have a strain that can produce high concentration of ethanol. Okay, so in this case, we can separate the two types of strains, whether they are ethanol sensitive, ethanol tolerant, and at the same time we gain information on the metabolites that are responsible for the separation. Okay, so in summary, multivariate data analysis, or MVA, is an approach to analyze complex multidimensional data composed of multiple variables. Examples are the principal component analysis, hierarchical clustering, and discriminant analysis. And MVA can help in gaining useful insights into large data sets and obtain relationships among the variables. So among useful applications is for the determination of silent phenotypes and quality attributes. So lastly, I would like to just give a brief introduction about our research group. This is our research group, Food and Biomaterial Engineering Research Group. Please go to our website if you are interested in our group. These are just some of our products or research. Yeah, we have some products related to high energy, nutrient dense energy bar. Okay, which are designed for to be used during emergencies or as a supplement. And then we have this tea from OPT, the oil palm trunk, which is the byproduct during the palm oil processing. And also we have research on smart packaging and also some related to dairy bio-based products. Okay, with that, I would like to thank the organizer for inviting me to talk in this conference. Please contact me if you have any questions or if you're interested to collaborate. Thank you and have a nice day. Thank you, everyone.
Thank you so much to Dr. Zanaria for the very interesting sharing on your research regarding metabolomic and also the multivariate data analysis. You gave many practical examples. I'm sure it is very useful for the young researcher. Okay, so please feel free to post your questions in the chat box. Yeah, we will leave until to the forum session for further discussion. Thank you, Dr. Zanaria. Okay. Next, I would like to invite Dr. Febrian Rushidi from Universitas Air. Okay. Today, you will be, Dr. Feb, are you there?
Yes, I am here. Can you see
Yeah.
me? All right.
Yes. Thank you for coming. Yeah, I can see you now. Thank you for joining I-Bes 2022. Are you ready to share your slide? Okay,
Yes,
today
I'm
your
ready.
talk. Yeah, please do. Dr. Feb is from Universitas Air. Today you will be talking on quantum mechanical approach to understand biological process from the Faculty of Science, yeah, Department of Physics. Okay, Dr. Feb, the floor is yours.
Thank you, Prof. Lee. Can you see my screen now?
Yes, I can see.
Yes.
Very good. Yeah.
Thank you. So I will take my chance to introduce to you quantum mechanical approaches to understand biological processes. And my name is Febdia Rusdi. I am a physicist, and this is how we see the reality of life. Oh, wow. And my talk will talk, my presentation will be divided into 4 parts. First, I'm going to talk about the title itself, and then I will raise the fundamental question, and finally, I will discuss about some study cases that we already done. And finally, the conclusion, of course, it is about the loose end. The first part about the quantum mechanical approaches to understand biological processes. Of course, first we need to get familiar with quantum mechanics. What we mean by quantum mechanics is first objects represented by wave function psi, and hold on, this is annoying. And all measures quantity q are the expectation value of their associated operators. This is the formula. The wave functions are the solution of the time-independent Schrödinger equation. Of course, we are familiar with the Schrödinger equation. And the solutions are in a set. They are orthonormal, complete, and they provide stationary states, and any possible states are the linear combinations of the wave functions. In many electron systems, such as atom other than hydrogen atom, molecules, enzyme, and practical everything around us, the material wave function phi is the Slater determinant of all electron wave functions. So we calculate like this, determinant of the Slater determinant, which accommodates the Pauli exclusion principle. Because of the electron-electron interaction, we have many problems. Now we have to consider not only about the charge interaction, also about the spin interaction. Now, of course, some of us will wonder, what is this? Is this quantum mechanics class, or did I just join a wrong seminar? Of course, you are not joining the wrong seminar. It is just biological processes are constructed by chemical reactions. I don't say that, it is said by our hero Linus Pauling. And chemical reactions are all about electron-electron interaction. So if we want to understand the biological processes, we have to understand chemical reactions. If we want to understand chemical reactions, then we have to understand electron-electron interaction. And electron-electron interaction is about quantum mechanics. Now we are talking about the chemical reaction. This is the way to understand biological processes. What did Pauling mean by a reaction is electron-electron interaction? There are two ways to represent chemical reaction. This is the common way, we find it in textbooks, a basic textbook, and this is the second way, where we present the chemical reaction through electron energy level diagram. This is the reaction coordinate, and this is the energy. A plus B is the reactant, and the product is C and D, while we have the activated complex in the transition state here. We can engineer the process, the reaction, so we can bring down the energy barrier like this. Now we have two transition states. Or we can, we call this F is the early transition state, fast reaction. Or we can delay the transition state, something like this. The red one, pathway number 3, and we call this as late transition state. This is slow reaction. Or we can involve surface catalyst, and usually the reaction pathway would be like this. Enzyme, typically the pathway number 2. Now, the chemical reaction in energy level diagram is equal to quantum mechanics. How do we see that? First, the pathway is actually the potential energy surface, this term. Second, we have two minima and saddle where the gradient is equal to 0. Minima is this one, G, product, also K, M, and also and saddles is E, F, H, L, all of the saddles. At minima, which means A plus B, G, K, M, N, C plus D, J, are for the ground states. While the saddle yield to transition state, or we call it activated complex in chemistry. And Schrödinger equation says that if we want to get C, the solution C, then we have to know the potential energy surface. And potential energy surface is all about electron-electron interaction, as Pauling says in the previous slide. Therefore, the electron-electron interaction dictates the reaction. This is what Linus Pauling said in the Nature of Chemical Bond, 3rd edition, Cornell University Press, 1960. All right, so we have biological processes, and we have the Schrödinger equation. From bottom to up, basically what we physicists see the problem, while experimentalists will see the problem from top to bottom. And reaction pathways, the meeting point of theoretical and experimental studies. Here we can verify both the theoretical aspect and experimental aspect. Reaction pathway help to predict unstable intermediates and transition state which are impossible to observe directly. From the theoretical perspective, quantum mechanics, electron-electron interactions proportional to the molecule's size and number. And it is impossible to construct the correct potential function, let alone to solve the Schrödinger equation. And physics let us simplify the problem. If we cannot simplify it, it implies that we do not understand the problem. That's the basic in physics. Problem simplification means modeling, and modeling we approach from the quantum mechanics. Now the third part of the title, the approach. The Nobel Prize in Chemistry 2013, taking the experiment to cyberspace, these three gentlemen make it possible to find the detail what happened exactly during the any chemical reactions using computer. And before that, before Nobel Prize in Chemistry 2013, before that in 1998, these two gentlemen make it possible for us to use computer to solve the equation for any problem in chemistry. And that's why Paul Dirac once says that basically once the Nobel Prize in Chemistry in 1998, the theory of chemistry is basically finished, kalas. Long story short, in 1926, Schrödinger provided an equation of motion for electron using quantum mechanics. 1954, Linus Pauling tailored quantum mechanics to understand the nature of chemical bond. Basically, Linus Pauling used quantum mechanics to explain chemistry. And 1998, Kohn developed quantum mechanics for many electrons and to solve computationally, and Popol developed the code to do it. 1913, Kaplus, Leavitt, and Warshall demonstrated the power of quantum mechanics in complex chemical systems through the computational chemistry. Usually, the work of Kaplus, Leavitt, and Warshall, we actually already enjoy it. We got many technology based on chemistry from their work. In 2019, here, Research Center for Quantum Engineering Design was established in our faculty in Universitas Air langga. Inspired by their great works and other things, we are motivated to implement quantum mechanics on chemical reaction modeling in biological processes. What we need is first established problems, good imaginations, and appropriate computing facility. Now, we come to the second part, the fundamental question. First, how do we model the problem? This is the simple way to understand how we model problem. You see the left part and the right side of the figure, it is, we familiar with this figure already. And we know that this figure is a model of the reality. Like for example, we have in the left side, we have the mountain. We have also the mountain in the right side. We have cloud. We also have the cloud in the picture. Then we have the tree. We also have the tree in the picture, in the model. Then we have house. We also have house. And then the paddy field. We also have the paddy field in the right picture. And finally, the famous road. We also have the famous road in the picture. So we know how to model since in the kindergarten. And one thing that we don't realize, but we do it actually, is the sun. Without the sun, we don't see anything. That's why there is no sun here, but this figure, the sun, is to model that. That's why we can look the beautiful picture in the left. But the fundamental question is why we never have the model exactly like in the real. We know that this is not the real, but we got everything we need from the real picture. The answer is first, level of understanding of the problem. Second, imagination based on physics. Sometimes we can imagine that, but we don't have the law to tackle the imagination. And finally, the ability to compute. And well, basically in short, because of our limitation. But we use this limitation to guide us to conduct the research. So number one, level of understanding. And then after we understand the problem, then we imagine the problem based on physics. What kind of rule, what kind of law that we can use to understand, to take the problem into physics area. And finally, once we have the imagination based on physics, we can compute based on quantum mechanics. And basically, this is what we do. We learn the cases that people already established the knowledge, check whether the case, for number 2, check whether the cases can be drawn into the energy level diagram, the pathway, and finally decide appropriate methods to calculate the electronic state. And up to number 3, there are another step is number 4. We have to attract and guide students because we cannot do by ourselves. And finally, our student will select the case, not us. And once the students select the case, they will repeat the step into the first one, level of understanding. And finally, it is like a filter from process number 1, number 2, number 3, and like, the first student will have many problems and finally can focus only 1 or 2 problems. And using this method to model the problem, we have a theme in our research center, development of DFT implementation for chemical reaction modeling. So our focus on modeling, not about the result itself, but how do we model the problem? How close, how good our model, so we can understand the experimental results. And finally, we have 5 case study already done in our research center: photodynamic therapy, Alzheimer's disease, antioxidant, renewable energy, and computational method. We also develop our own computational method here. And some, some energy correction, catalyst, we also involve catalyst, and this is our main goal, reaction pathway. We have to be able to construct reaction pathway from our case study. And your audience or participants can check our publication, our full publication in my Scopus author ID. Or visit our website, physica.fst.unair.ac.id, what do you call that, /TPRG. Now we come to the last part, the study case. First, I'm going to talk about acetylcholine neutral hydrolysis. The problem comes from this is common in our textbook, in neuroscience textbook, acetylcholine metabolism in cholinergic nerve terminal. And we see that here, I will not explain everything here, but it's quite good a figure anyway. We will got a problem when there is no acetylcholine goes into the post-synaptic cell. If there is no or lack of acetylcholine transfer from this side to that side, then we will get memory loss or Alzheimer's disease. And according to cholinergic hypothesis, there are 2 possible why it happens. First, from the creation of the production of the acetylcholine itself, or second one is the hydrolysis of the acetylcholine is too much, too fast. So if we want to study the Alzheimer's disease using quantum mechanics, we will attack between we have to select either 1 or number 2. And number 1 inside the neuron, an acetylcholine coenzyme is a huge molecule here. While the second one in the hydrolysis, it is outside the neuron and it is neutral hydrolysis of ester. So of course we will tackle this problem first to ensure that we can use quantum mechanics to understand the acetylcholine, for the Alzheimer's disease problem. And this is done by my student, motivated by our professor in Osaka University in 2014. There are 2 facts. Fact number 1, neutral hydrolysis usually slow. Fact number 2, cholinergic hypothesis pointed out that the depletion of acetylcholine was due to the high rate of acetylcholine hydrolysis by the acetylcholinesterase enzyme. This is done by my student. Conclusion, fact 1 doesn't match with fact 2. Of course, it will raise the question why. Now the question now is what makes the rate increases? And can be answered by reaction pathway. This question can be answered by the reaction pathway. So we will make our goal reaction pathway like this. So this is the acetylcholine and this is our goal. And we make a workflow, several stages to get to the solution. Stage 1, stage 2, and stage 3. This is the research interest and this is the environment. So we increase the environment complexity during each stage. And we got some publication already, 1, 2, 3, and there are some manuscripts are being written. And also in the step 3, my student used it for doctoral research in Osaka University. And since it is already complex, using enzyme and docking is the common way to handle the problem, but we don't want to use docking anymore because it is typical. We want to use machine learning method, using a machine learning method to involve enzyme in this study. And case number 2, radical scavenging activity. It is about melinjo, genetum genome. It is I cannot read it, but I know that in Indonesia we call it awas asam urat because it rise gout attack in our body. Motivation, a challenge from Professor Heni Rahmawati, a pharmacy from Institut Teknologi Bandung in 2016. There are 2 facts from Professor Heni Rahmawati. First, Gnetin C is the main antioxidant in melinjo, but also Gnetin C is not the main. Instead, it is only the precursor for antioxidants. So which one is true? Fact number 1 or fact number 2? This is 2 different studies. And we also need to answer that by reaction pathway. We also develop the method to solve the problem, and we have 3 stages. We also have several publications already. Also, this problem becomes dissertation of Dr. Vera Hornisa from Institut Teknologi Bandung. And at stage number 3, we find many problems already. After we discover several things in stage 2, we extend the problem, and the problem becomes doctoral research of Lucia, also in ITB, and also master research of Roishkatul Madinah in Universiti Kebangsaan Malaysia. All of them, all my students, but now this is already graduated. This is already still in the school, and this is still active in the school. Now the solubility in water solvent, it is extension of the case number 2 actually, and I already explained it just a little bit. Perhaps we can discuss it in the forum later on. And finally, what we can conclude from the presentation, first, we presented our road from theoretical physics to biological application without losing our identity as physicists. We are making progress slowly but rigorously and recognition. Also, we need to employ hybrid quantum molecular mechanic, and machine learning approaches in this field. And finally, terima kasih.
Thank you so much to Dr. Feb for a very interesting angle, electron interaction to look at chemical reaction. It is something very new to me, but I hear with full interest. Also, I posted a question for you in the chat
Thank
box.
you.
Okay. Yeah, I guess we can have about 10 minutes of discussions and one for each of the speaker, I guess. So let us start with the first question to Dr. Ali. Yeah.
Yes.
Would you like to elaborate, especially in terms of the challenges to formulate or research a product in the enzyme form as compared to if we formulate in the microbial inoculant format? Yeah. Would you like to elaborate on that? Yeah.
Yeah, okay, thank you very much for the question. So I think it's depend on the what application will be used because like in paper industries or detergent, we need to isolate the enzyme. We don't need to make the enzyme pure, but at least we isolate from the organism, from the microorganism. But for example, for with treatment, then you're right that it will be very expensive to isolate the enzyme, or let's say to lysis the enzyme is also difficult in the large scale. Then I think it is better to use whole cell biocatalysis to apply application in the waste removal. But again, that it depends on the what application will the enzyme will be used in the industries. Yeah. What do you think then?
Thank you so much for your response. Also, I was quite excited to see your product, the prebiotics that you have produced on the xylitol as a oligosaccharide, right, to promote that kind of degradation. Do you also have any commercial product already formulated on other microbe or enzyme?
Yeah, it's Prof. Newman already formulated the enzyme for paper industries and also for feed. So
Animal feed.
Animal feed, yeah.
I see. Yeah,
But
congratulations.
all are in the isolated enzyme, not from the wholesale biocatalysis. Yeah.
I see. I see. I
Yeah.
suppose it is for commercial applications, so it is in the extracted enzyme
Yeah,
form.
it's
Okay.
in the extracted form. Yeah.
Thank you so much for your sharing. Very interesting. Okay. Yeah. So next we will like to go to the next speaker, Dr. Zanaria. Is it possible to apply such approach, yeah, the multivariate data analysis to identify which enzyme are active in a particular conditions? Question from Dr. Ali. Yeah.
Okay, thank you for the question. Yes, it is possible, but the thing is that from the metabolomics analysis, we will get data in the form of the concentration of metabolites. So what you can do is you can actually map those metabolites to the metabolic pathway. I'm not sure what kind of microbes that you are dealing with, but for me, for example, if you're dealing with Saccharomyces cerevisiae or E. coli, they are very common. So you can actually refer to many online database. So you can just put your data, your metabolite concentration data, and from there you can actually map the metabolite data into the metabolic pathway, so you can know which pathway that are actually affected. For example, let's say the glycolysis or the lipid metabolism, and then from there you can see if you already have the information, what kind of proteins or enzymes involved in that pathway, then you can pinpoint your enzyme lah. But if not, then probably you will have to see similar metabolic pathway, and from there probably have several candidates. And I think you need also to confirm using other methods such as the transcriptomics or proteomics, yeah, to confirm your targets.
Okay, so basically by the technique we determine the metabolite and then correlate the metabolite with the enzyme. Is right?
Yes.
Okay. Yeah. Thank you very much, Dr. Janaria.
You're welcome.
It's a very interesting questions. Yeah, maybe you both can have collaborations. Yeah. Okay. Yeah.
Nice.
Okay. So the next question is for Dr. Fabian. You can read, right? It's from me.
Yes,
it's quite
I
long.
read your question, Prof. Lee, and I can comment
Yeah.
that all of the possible answers that you already written is correct. But I can tell you that the biggest problem that become the bottleneck, if you want to make a Pareto chart, so the biggest point is the number of students, Prof. Lee. Why? Because not so many students are eager to do this kind of research. Why? Because they are afraid, Prof. Lee. They are afraid about the equation. Schrodinger equation is so people are scared in the. But actually, we don't use that equation anymore. We use computer. But of course, I always insist my student knows what happened in the box, not just using like calculator. You see, because without knowing what happened in the box in the computer, they cannot analyze it. Computer always calculates anything, but how do you figure out the number is correct or not? How do you interpret the number?
Yeah.
About
So
the complexity of yes.
I suppose not just the physics, they also need to be very interested in chemistry, right?
Yeah, but that's not it's not difficult, probably, because we have many chemists in UNAIR, like Dr. Ali. He is a good chemist. But I believe people like our colleagues in chemistry, they don't know too many things in physics. And they need us actually to understand what happened, that something like in the reaction, we have an intermediate state, a transition state. They don't see it in the experiment. They need us actually. So
Yeah. So how do you improve the communication between physics and chemists, so that each other can understand? Communication takes time.
yeah, that's true, Prof. Lee. That's true. Usually, a long time ago, we have a meeting, informal meeting. Like I usually come to Dr. Ali to have some discussion, or Professor Uco before. But now, since pandemic, we have Zoom meeting, we have Webex meeting, but we don't.
Yeah.
We use it just for formality in the end.
Yeah,
But
yeah.
you're correct. You are correct.
Yeah.
We have.
So can I say that electron interaction is very powerful, but the most important is the chemistry between the researcher.
Yes, that's true. That's true. That's true.
That's right.
Prof. Lee, I can comment something else that we enjoy many program right now in chemistry. We also enjoy many textbook already, but that based on the work of the Nobel Prize in 2013, But we don't realize it because there's too complexity in the behind the scene. We just take it for granted. Many free software in the internet use that algorithm, but we didn't know.
Yeah.
And from
So
2013, because of that, the Nobel Prize work in 2013, now they can create machine learning, like you say, the data mining. So there are two approaches right now. The traditional one using quantum mechanics, molecular mechanics, and the second one is the machine learning. But machine learning must learn something. They learn from the traditional approach. So
okay.
if the traditional approach are wrong, the machine learning becomes stupid.
Yeah.
So these two cannot separate. Cannot separate.
So it sounds like such a exciting future research area that we need people like you, passionate people, to reconcile the interpersonal skill and multiple disciplinary research. Yeah, so this is really matching the theme of our conference. Yeah, okay. So I'm
Thank
sure
you, Prof. Lee.
the research of everyone nowadays will need more collaborations across different disciplines. Yeah, okay. So I thanks all the speakers. Maybe
Thank you very much.
we can ask if there is still any question from the floor. Yeah, we have 2 minutes. Yeah, I hope we can have a 5 minutes break before the next session at 11. Okay. As I can see, there is no question in the chat box. Okay. Thank you. Thank you so much
Thank
for
Thank you
the
very
you,
much.
wonderful discussion.
Prof.
And
Lee, Dr. Zanira, dan Dr. Ali. See you
yeah.
in campus,
Thank you
Dr.
very
Ali.
much. Yes. Hope to see
Thank
you.
you. Yes, I see you again. So I think we can have a 5 minutes break and we come back at 11. Yeah, thank you all. Thank you. Yeah,
Okay, bye.
yeah. Okay. your title will be on seaweed-based hard shell capsules productions, also from Universitas Air Langga. Okay.
Yeah.
And you are from the Innovation Seaweed Products Teaching Industry Lumpur Laut Center, right? Okay.
Yeah.
Okay, so I would like to invite you to deliver this talk now. The floor is yours. Thank you.
Okay. Bismillah. Thank you very much, Professor Lee and Dr. Sulaiha, for the introduction. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. First of all, I would like to say thank you to the committee organization to allow me giving speech today. I'm Prativi. In this session, I would like to talk about a seaweed-based hard shell capsule production. Why seaweed is used as a material for capsule? As you know that Indonesia is consists of many islands. Indonesia is a tropical country where it has much of sunshine, it's much of water, and this is important for the growth of the seaweed. Indonesia is famous of set of warehouse of seaweed. The cultivating of seaweed doesn't nature the fertilizer, so it's benefit and profitable for the farmer. The farmer only provide long line ropes for growing of the seaweed. The seaweed could be harvested within 45 days. It is very fast. As we know already, seaweed is rich of mineral, about within 10 higher than plants. In addition, seaweed is also source of secondary metabolite for drugs and cosmetic. Wood have 8,000 of seaweed. Producer of seaweed in the world is a strength of the nation. The biggest producer is China, and followed by Indonesia, Philippines, Korea, Japan, Malaysia, Vietnam, and so on. This is a strength for Indonesia in the world's global trading. Luning reported that Indonesia has 628 of seaweed, but after Expedition Sipoka and Weber, they said that Indonesia have 782 species. There are belong to green algae, brown algae, and red algae. But the two family, blue algae and crayfish, are not identified. So what's happening with our seaweed? Where is our seaweed exported? The Director General of Marine and Fisheries Ministry, Dr. Selamat Subiakto, said that 80% of raw material for export in ASEAN, Chile, China, Europe, Japan, Korea, and Russia, and 20% of the product for food, beverage, drug, and cosmetic. After export, returns with a high price is very confused. So we try to contribute by exploring and producing healthy material from seaweed based to achieve the independent production scheme. This is an opportunity for reducing export of raw material of seaweed. Indonesia consists of 87% Muslim, and they need a halal capsule. And how many rupiah that university gets from the production of capsule. 1 kg of raw material is about 4.8 ringgit. Yeah, 1 kg of karakenan extract from Ekima, about 60 ringgit. And after get a capsule 1 kg karakenan, we got 10,000 of hard shell capsule, about 2,200 ringgit minus the production cost. For example, salary, electricity, material, base, and maintenance. Maybe we get balance 100 ringgit. So to increase the revenue of farmers, producer, and stakeholder, this is a CVIT in many places in Indonesia. Empowerment of the farming communities. And 5, the cell capsule can be substituted as the partner of gelatin as a substrat material. Why a substrat material? Because we are not produce gelatin. Gelatin is imported from India, Thailand, and Bangladesh. So you know that in India are the coast lards, SARI perfectly, are gelatin of cows separated from gelatin of pig, are the machine wash suitable with Islam rule or SARI. So Undang-Undang CPH in Malaysia called JAKIM, Jabatan Kemajuan Islam Malaysia, issued a statement that a product of food, beverage, drugs, and cosmetic must halal. So it's making the hard capsule is a new product, and this is need in Indonesia. And what is gelatin? Where does it come from? Gelatin is made from the boiled bone, skin, and cartilage of animal. You said you saw this that more porcine 42 and cow maybe more than 42. So why the gelatin from pig is cheaper than cow? You know that pig mating in 6 months and cow 18 months and give birth 7 until 12 in 6 months and cow 1 in a year. So the price of the pig is cheaper than cow. So how many gelatin hard shell capsule that need Indonesia? We need 6 billion capsule MT. 1 billion is from produced to industry of capsule by Capsulindo Nusantara and capsule gels. Capsule gels belong of America, and 1 billion is imported from China. This is a subhat. We don't know from China is halal or not. We don't know. So we try to make a capsule from seaweed. And how to extract? How to extract of the seaweed base of head shape capsule. First of all, the seaweed were dried, green into small pieces and soaked and 7 KOH. And the alkali treatment of karakenan, this is neutralized by HCl, become the semi-refined karakenan, and karakenan wash with calcium hypochlorite to produce refined karakenan. The refined karakenan is the base of the hard shell capsule. So how to make the capsule in the laboratory? The substance of the capsule component are made and heated until melt, and then poured in the dipping bar, and pins were dipped in the dipping bar and let it in overnight and you get a capsule. It's very simple. But since we produce the capsule, we have 30% of residue for what? Yeah. Yeah. So we try to innovation of capsule. First, we make a capsule combination between kappa carrageenan and alginate. Alginate is very expensive because alginate is extract from sargassum. Sargassum is brown algae. So the price of combination kappa carrageenan alginate is 3 times compared to the gelatin. So I will to reduce the price and I combine the kappa carrageenan and stocks, cassava stocks. So the price is the same of the gelatin, but the truck is very difficult to release because the stock is have a mass is very big. So I will try to make the third formula combined between a kappa carrageenan and maltodextrin. Maltodextrin is extracted from barley or wheat. This is a innovation of Civitas capsule and with utilization. We have three formula: caral, carrageenan alginate, karsa, carrageenan and starch, and carrageenan maltodextrin. During the production, it has some residue about 30%. So the residue, we try to make the glass, plate, and straw, but we don't have that machines. So I hope that I get a machine for the use the weight of the weight. Triple helix and an ideal research and innovation. The triple helix is based on the interaction between the three following elements. There are initial role, university, industry, and government. The university is generate a knowledge, innovation, and new idea as basic research, and the business yes, we call the ABG. The business that industry is converting the ideas into product and innovation processes, and the government regulating market and sustain role and demand of strategic. As the formula HAT capsule, we perform at industry scale in PT Capsulindo Nusantara industry. This is belong to a nation. So but the production capacity is only 800,000 per day. This is a regulation from President Republik Indonesia about acceleration of non-food industry of seaweed-based hard shell capsule. In 1918, Universitas Air Langga received a set of capsule machine authorized from Ministry of Industry Republik Indonesia. This is a fitting. Fitting is a mixed material, and this is a printing of capsule, and this is a drying of capsule, and this is a joining of capsules. We tried three formula, Caral, Carpa, and Carex, but maybe it's many trying, many experiment are needed because to make the requirement of standard capsule as referred to WHO or US Pharmacopoeia or Department of Health, Republic of Indonesia. So after we produce the capsule, so you need the specific properties of the capsule, for example, humidity, logs capsule length, mass, body and cap diameter, and disintegration time. USP, US pharmacopoeic requirement that gelatin have has disintegration time 30 minutes, and Ministry of Health Republik Indonesia for gelatin 50 minutes, and PT Kapsulindo Nusantara for gelatin 7 minutes. But it's very interesting. The Caral, Carsa, and Carets in 6 replicates, 2 until 3 of time of the gelatin. This is interesting to develop and to create how make the capsule fast disintegration and fast release of drug in the capsule. And then another specification is width and length. Width maybe is suitable with requirement or standards, and body length is okay, and specific thickness and disintegration is, I think, I said before that disintegration of the our capsule is 2 or 3 times with the gelatin. So we must improve this disintegration time. The another specification is moisture balance. Moisture balance is suitable with standard and requirement of WH, and is indifferent. Yeah, this is as content. As content, gelatin only 1%, but hard shell capsule from seaweed it's bigger than gelatin, because you know that gelatin is a protein, but seaweed is a polysaccharide. You know that polysaccharide, many of atom carbon and many of minerals, so the S content is bigger than gelatin. It's important to detect, check if heavy metal. Heavy metal, I have experiment that non-detect, but this is cuprum, but we don't use this because it's not requirement with WHO, but we use this. The requirement test by USP for non-gelatin capsule is also refer or my capsule. This is, for example, viscosity, loss of drying, residue, pH, heavy metal, and so on. Another test, we try to this solution erythromycin in vitro at pH 1.2, 4.5, and 6.8. This pH is represented in gastric and intestine. First time I tried to 3 replicates that erythromycin release at pH 4.5, and after many replicate is 6 replicate, that's erythromycin dilute very easy in the pH 6.8. You can see the journal. And I also tried salicylamide and for the carrots. And the salicylamide is better released at the pH of 4.5, and also the paracetamol as well as salicylamide is better released at a pH of 4.5. This is a teaching industry of seaweed at Langga University, and my problem is processing to make a capsule are not simple. Manufacturing times become slightly longer because we also much many experiment. You know that today I experiment from seaweed from Ambon is different. I experiment next seaweed from Madura or seaweed on NTT. So I always check the viscosity of the seaweed. So it's not simple. What is the beneficial of the vegetarian of plant capsule? The plant capsule for vegetarian population and Muslim, low moisture content, not cross-linking, no allergy in patient, for and safe for kidney and liver disease patient, ideal for moisture sensitive and hygroscopic ingredient and no need of preservative. So in the progress research, we collaborate with University of Malaya through the joint research schemes in 2022. We are improve the formula of the capsule to reduce disintegration time and fast dissolution at pH 1.2. This is a research group of seaweed-based innovation products. Professor Amin, Dr. Trivinarni, Dr. Andi, Professor ST, Dr. Siti, and me. Thank you very much for the recognition.
Thank you, Professor Prativi, for the interesting sharing on the seaweed-based capsules. Yeah. Later on, we will have more discussions during the forum session at the end of the presentations. Yeah. Okay. I may have one question later on. I will type in the chat box, mainly related to the economic feasibility as compared to the conventional gelatin capsule. Okay.
Yeah.
Yes. So we can do this Q&A at the end of the session already. Also, there is some question in the chat box. Yeah. Okay.
Yeah.
But we will leave it to the end of the three presentation. Yeah. Thank you, Professor Prativi.
Thank you.
Okay. So next, I would like to invite the second speaker, Associate Professor Dr. Dayang Nurul Fairuz Abang Zaidil, to present on the topic regarding potential of galacto-oligosaccharide synthesized from sweet potato pectin using beta-galactanase. Associate Professor Dr. Dayang is currently academicians in UTM, based in MJIIT Kuala Lumpur campus. And Dr. Dayang, the floor is yours.
Hi, thank you very much, Prof. Lee. Can you hear me?
Yeah, I can hear you well.
Okay, I'll share my slide first.
How is KL today?
Traffic jam as usual. But
Okay,
everything else is good.
good. Okay.
Okay. Right, so this is the topic that I will present today. So, Assalamualaikum and very good day, everyone. Still morning, I think. Yes, good morning. So the topic I will share today is the potential of galacto-oligosaccharides, okay, synthesized from sweet potato pectin, okay, using beta-galactanase. It's specifically from Geobacillus mahadegio 05, which has been extracted and purified by my PhD students, yeah, which has graduated, Dr. Nur Faiza Ismail. Okay, I will share what is the finding from the study. Okay, my name is Dayang Nurul Fairuz. is introduced by Prof. Lee. I'm currently in MJIT, UTMKL. Okay, so the presentation outline, basically I will talk about what is oligosaccharides, the synthesis of GOS from two different enzymes, beta galactose and beta galactonase and beta galactosidase. Okay, then the factors affecting the GOS synthesis, and the final one is the synthesis of GOS from sweet potato pectin. Okay, so some brief introduction on oligosaccharides. Basically, there are four classes of carbohydrates, which are monosaccharides, disaccharides, oligosaccharides, and polysaccharides. And the oligosaccharides are influenced by the monosaccharide composition, the glycosidic linkages, and degree of polymerization. Oligosaccharides possess thickening ability, which can be used as texture modifier compound in food. It has gelling and stabilizer ability. Okay, it has low carcinogenicity of oligosaccharides would be useful as an alternative sugar. Okay, especially for the diabetic people, and also substitute for this sugar. Yeah, in confectionery. Then recently also oligosaccharides are noticeable for prebiotic function in the food. Okay, then the sources of oligosaccharides have been explored in biomass of cassava residue, apple pomace. There are varieties of sources of oligosaccharides, especially from the byproducts from the industry. And then in nature, oligosaccharides are one of the components of plant fiber and can be found in a variety of fruits and vegetables. So you can see some in onions, asparagus, soybeans. Yeah. So basically, it's from nature, natural sources. Okay. Then, besides the natural sources, okay, oligosaccharides also can be synthesized from different methods. Yeah? It's either chemical synthesis, microbial synthesis, or enzymatic synthesis, or chemoenzymatic synthesis. And there are different types of methods which we can synthesize oligosaccharides besides the natural sources. Okay, for example, for this chemical synthesis, it's a complex procedures. It has side reactions, and also some of the chemical used are hazardous. And for chemical synthesis, it's involve glycosylation process. It requires additional manipulations between the steps and need to be repeated until the chain of oligosaccharides will obtain. Okay. While for microbial, it's using stability of the plasmid harboring cells. Then enzymatic synthesis, it's a mild condition with temperature probably, it depends on the enzyme that are used. And it's specific, product specificity. Usually, there are three major groups of enzyme used to synthesize these oligosaccharides. For example, this glycosyltransferase, glycoside hydrolase, and also transglycosylase. Okay, then we have this chemoenzymatic synthesis, which combine chemical and also enzyme reaction. It's either concurrent or sequential reaction, and also this using this chemoenzymatic approach, 31 human milk oligosaccharides was successfully established. Okay, when the three core oligosaccharides were chemically synthesized prior to elongation by 4 robust glycosyltransferase. So we can use this galacto-oligosaccharide for to produce human milk oligosaccharides. Yeah. Okay. So these are some examples of oligosaccharides, which has different functional benefits. Okay, as you can see, we have fructooligosaccharides, we have galactooligosaccharides, we have glucooligosaccharides, and different types of other oligosaccharides which has different functional benefits. For example, for xylo-oligosaccharides, it stimulates immune system, improve absorption of minerals. We have galacto-oligosaccharides which also increase immune response in white shrimp. Gluco-oligosaccharide reduce growth of certain pathogens and increase antimicrobial activity. So different types of oligosaccharides has different functional benefits. Okay, then we go into galacto-oligosaccharides specifically. Okay, so galacto-oligosaccharide, or also we use GOS as its abbreviation. Okay, GOS comprises of galactose, lactose unit from 2 to 10 degree of polymerization. It's one of the most studied oligosaccharides due to its structure mimics the nutritionist component found in human milk. So it's most used as human milk alternatives. Okay, so for decades, GOS has been produced from lactose, which is found in whey, and abundant byproduct generated from casein and also dairy industry. So GOS can be produced by transglycosylation reaction of beta galactosidase from lactose. Okay, and also galactan, which is made up of galactose unit, is also becoming an alternative substrate for the synthesis of GOS by hydrolysis reaction using beta galactanase. So, and galactan can be found in various sources such as animals, microbes, fungal, and seaweeds. And it has been growing interest in using pectic galactan as GOS sources. So these there are meaning that there are two different methods to produce GOS, either by transglycosylation reaction or by hydrolysis reaction. Okay, there are two types of enzymes that are used. One is beta galactosidase and one is beta galactanase. Okay, so these are the two types of enzyme. There are and also two different reactions. One is transgalactosylation using beta galactosidase. Yeah, you can see the transgalactosylation reaction on the left side. Okay, which combine the two lactose together and becoming the linkages produce the GOS, and the other side with beta galactanase, which we have galactan. Okay, then hydrolysis reaction occur to produce GOS. Yeah. Okay, this is the mechanism of action of beta galactanase, in which the hydrolysis occur in the to the substrate, which it cleave the galactan backbone. Yeah? So then what are the factors affecting the GOS synthesis is that we can use, there are basically four main factors. The first one is the sources of enzyme, because this where we synthesize the enzyme from. Okay, we get the enzyme from is that the sources will contribute to different type and yield of the GOS produced. Since the enzyme, the temperature of the enzyme, the optimum condition of the enzyme, how does it work with the galactan, or also of the source, the substrate that we use, also will affect the synthesis of our GOS. Yeah? Then the pre-treatment of the substrate is what type of pre-treatment that we use. It either will the pre-treatment will open up the structure of our substrate. Okay, then it will make the substrate more accessible to hydrolysis. Yeah? If let's say the structure of the substrate is more open up, then the hydrolysis will be more easier, and will be the reaction will be faster. Okay, Then the source of substrate, composition of the plant polysaccharides are diverse according to the sources, the part of the plant, which part of the plant they are used, either the leaves or the bark or the byproduct, which part of the plant's substrate they are used. Okay. Then the reaction parameters, especially the temperature, the pH of the reaction, what kind of equipment are used. So all these are affecting the synthesis of oligosaccharides. Okay. Then okay, so now I move into pectin. Okay, what is pectin? So in general, pectin is polymeric composition of primary cell walls in plants, which consists of approximately 35% of pectin, 30% of cellulose, 30% hemicellulose, right? And the major constituent of all plants make up approximately 2/3 of the dry mass of plant primary cell walls. So pectin provides structural integrity, strength, and flexibility to the cell wall and act as a barrier to the external environment of the plant. Okay, then usually this pectin in industry, it's used for food gelling agent. So mainly it's produced from fruits, for example, from citrus peel, apple peel, and it's also used as fillings, sweets, stabilizer in fruit juice. Yeah, and it's also a source of dietary fiber. Okay. And so now one of the sources of pectin, which we can get from local, yeah, basically in Malaysia and Indonesia and Thailand, okay, in our region. So it is one of high pectin content is sweet potato peel. Okay, sweet potato is a plant that belongs to this convolvulaceae. I don't know how to pronounce that. Okay, it contains high dietary fiber, minerals, vitamins, and antioxidants. Okay, and then the residue, the potato residue, the peel, contain about 15% of pectin on a dry matter basis, composed of 6 neutral sugars. Yeah, pectin. Later on, I'll show you the structure of pectin, and it contains also galacturonic acid and glucuronic acids. Good. So this is the structure of pectin. How does this? Where is the galactan? So you can see the galactose unit, the green color on this right on the rhamnogalacturon 1 side here, contains galactose unit, which contribute to the galactan. Okay, then from there we can hydrolyze. Okay, we can hydrolyze the pectin to get this GOS. Yeah, because when you can see the structure of pectin, it contains a very long backbone of galacturonic acid, and we have to hydrolyze first the long backbone of the galacturonic acid to in order to hydrolyze the rhamnogalacturon 1 to get that galactan, okay, and also the GOS. Okay, then as you can see that pectin has different degree of esterification. So depending on the percent of this DE, so more I can see that if the galacturonic acid, they are esterified with methyl alcohol. So the degree of esterification, meaning that is the percentage of the methyl ester alcohol in pectin. So if the DE is less than 50%, then it's a low methoxyl pectin. And if it's more than 50%, then it's a high methoxyl pectin. So this different degree of different DE will determine how the pectin will behave as gelling agent. Either it will use calcium ion, or that is for low methoxyl pectin. But for high methoxyl pectin, it will use a sugar. In addition of sugar to stabilize or to gel. Okay, so for this study, we would like to investigate the potential of pectin extracted from this sweet potato peels, okay, for this production of GOS, okay, using the beta-galactanase enzyme, okay. So for the methodology, we use extraction of pectin from this SPP, sweet potato peel, using hydrochloric acid. This is an optimum condition that we have performed to get that temperature and also pH. Then we analyze the pectin, okay. Then after that, we hydrolysis reaction of SPP pectin using beta-galactanase. Then we analyze the GOS. Okay, this is the detailed method for that extraction of pectin. So we use optimum condition at 60 degrees Celsius, 90 minutes, and also pH 1 of hydrochloric acid solution. And we analyze the yield of pectin and also the degree of esterification. Then for this hydrolysis of sweet potato using beta-galactanase, after we hydrolyze after we get the pectin, okay, we treat the pectin with endopolygalacturonase, okay. Then at pH 5.5. After that, then we react with the beta-galactanase, okay, at 35 degrees Celsius. This is the optimum condition of this enzyme, okay. But prior to that, we treat it with endopolygalacturonase so that all this, the long backbone of the galacturonic acid will be cleaved first in order for this beta-galactanase to work on the to hydrolyze the galactan in the rhamnogalacturon 1 backbone, okay, chain. Then after that, we to stop the reaction with accordance to beta-galactanase assay. Then we analyze the GOS using this monosaccharide analysis. Okay, for the results, okay, this is the composition of the sweet potato peel to make sure that verify there's pectin inside this sweet potato peel. So you can see that pectin is about 16.7%. Okay. So this is how we calculate the pectin yield. So the result is almost similar, yeah, a yield with previously also we have used alkaline hydrolysis, which is 16.8% yield. Okay, then we analyze the degree of esterification, which we get from FTIR. We get about 57.48% DE, which means that this pectin is high methoxyl pectin. Okay. Then, so for the monosaccharide analysis of this pectin, we use HPLC to see what is the monosaccharides available in that pectin. So we can see that there are galacturonic acid for the peak B is galactose, peak C is rhamnose, and peak D is arabinose. So all these monosaccharide, they are building blocks for rhamnogalacturon 1, which is found in pectin extract. Okay, so meaning that our hydrolysis from this prior to the beta-galactanase is able to cleave the long backbone of the pectin to get that rhamnogalacturon 1. Yeah. Okay, then for that, after the hydrolysis reaction of beta-galactanase towards the SPP peptide. So we can see the HPLC chromatogram. We get the galactose G1, G2 is galactobiose, and then we get galactotriose. So we get DP3 up to the DP3 galacto-oligosaccharide and galactotriose, which we get about 0.081 milligram per gram produced. It's not much, but there's still a lot of study to be done in order to produce a higher amount of GOS from this pectin. Then in conclusion, I can say that this pectin from SPP has potential to be used as substrate for GOS synthesis using beta-galactanase. Okay, GOS with DP1 to DP3 was produced from this hydrolysis reaction. We get about 0.081 milligram per gram galactotriose. Then to further investigate and also to improve this hydrolysis reaction, we can optimize this beta-galactanase for hydrolysis of SPP pectin for this synthesis of GOS. And also for further investigation for this potential of GOS, we can do probably the application of GOS from pectin, this sweet potato pectin, to be used in food applications, for example, as prebiotics, and also for the human milk alternatives. It can be further investigate. So yeah, these are some of the references used, and also I think that's all from me. Suddenly the slide is gone.
Thank you so much, Dr. Dayang, for sharing the pectin productions from the sweet potato peel. Yeah, just wonder how economic feasible later on in terms of yield. Maybe you can share. Okay, supposedly now we should have the last presentation from Professor Tijik. Professor Tijik, are you there? Yeah, I understand she has a very packed schedule today. Professor Tijik?
Yes. Oh, yeah. Sorry.
Yeah.
I'm sorry.
Are you
Yep.
ready to
I'm
present
here,
now?
Belle. Oh,
Yes.
okay. I try. Yeah. Is that okay? Unfortunately, my my flight is delayed, so I couldn't
Okay.
join on time. Is it okay
Yeah.
for others that I'm join for now?
Yes, yes, yes.
Oh,
And
okay.
are you able to project your slide? I know you just landed at the airport. Thank you so much to try to catch up, even though you just landed, yeah. And the presentation today entitled "Diversity of Bioactive Compound from Flamingia, Indonesia."
Yeah.
Are you able to project now?
Yes.
Yeah.
Yeah. Can I start now?
Yeah. Are you presenting from the airport?
Could you give me access to open?
Can you share the slide or you need some help from our side?
I can't open. I don't have access to open my PPT using this. Could you give me the access?
Okay,
Sorry.
maybe I will get help
Okay.
from
Yes. I think so. I'm not sure how to, because I'm not so familiar with the WebEx. I'm sorry.
Yes, I do understand.
Prof. Tijik, can I share from here?
Yeah.
Can I share your
Yes.
slide from here?
Sure. Yeah.
Okay.
Thank you.
Okay, yeah, that will be better. For your information, everyone, we will have a photo session at the end of the morning section after the forum. Yeah, thank you. Okay, so the floor is yours, Professor Digit. Yeah.
Okay. Thank you very much. Good morning and Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to apologize that I couldn't join earlier because my flight was delayed. Today, I would like to present my paper with diversity of bioactive compounds from the Flamingia Indonesia. Actually, Flamingia is the small plant. It is originally come from the India, but I don't know why we could find this plant in some area in Indonesia. Next, please. Yes. Next, please. Okay. Yeah. And before, yes. Actually, I can find the before the previous slide. Yes. Actually, the second slide, please. Yes. Thank you. We can find the Flamingia in the center of Kalimantan and also in east of Java. Since we know that this plant originally from India, we don't know how this plant can go to this the spread area from the to the center of Kalimantan and east of Java. So from these two area, we got three species of Flamingia, which is originally it should be 5 of them, but we got 3 of species in Kalimantan and as well as in east of Java. Next. Yes. So the Flamingia is I mentioned before, it's belong to the Fabaceae family. And actually from this species or this genus, we find several secondary metabolites such as the flavonoid and then the derivative. And also from this genus, we find some of these other chalcone and also the flavanone, which is this is have the distinctive characteristic compared to the other chalcone and flavanone, because it has the oxygenated pattern at the A and B rings. So the present, we know that there are some side chains that it's very interesting. The presence of the terpenyl side chains will enhance the biological activities such as cytotoxic, antioxidant, and estrogenic properties. In this event, I would like to report the variety of the compound from the Flamingia macrophylla and the Flamingia lineata. Next. Yes. Actually, we are working with Flamingia since 2019, and we have the first project we work with Flamingia macrophylla for up to 2020, and then after that followed by the Flamingia strobilifera and Flamingia lineata. However, for today, I would like to report only for Flamingia macrophylla and Flamingia lineata. From this Flamingia, we got a compound which is belong to flavonoids and isoflavonoid. From the flavonoid, we obtain several compounds, chalcone granulated, which is active as an anti-cancer. However, for the isoflavonoid, actually, once we got the compound, it's inactive to which is interesting that of 3 of this ring, it has the geranyl chain, and then this geranyl and with the hydro group and C4, it's it's undergo cyclization to make the Pirano ring. Next. Nah, actually, from this Flemingia macrophylla, we got a new compound which is flavonoid, which has the actually this is the chalcone, granulated chalcone. It has the geranyl at the C3 and the hydroxy at C4. So this hydroxy and the geranyl is undergo the cyclization to make the Pirano ring. And this other, the Fleming key, actually, it doesn't has the geranyl side or geranyl chains, but it has the methoxy group. And these two compounds, we call it Fleming P and Fleming Q, actually has a very active to the anti-cancer as well as the antioxidant. Such as for the Fleming P, it's active as a anti-cancer for the cell HeLa, and for TI, this is very active for 0.1. And for the Fleming Q, it's more active as a HeLa anti-cancer, HeLa cell, instead of the Fleming P. However, for the antioxidant, actually, the Fleming key is more active compared to the Fleming P. This is the characteristic of this geranyl in C4, C3, and the hydroxy in C4. It will influence the activity of this compound toward the anti-cancer cell. Next. As we know, like this is the chalcone from the Flemingia macrophylla, which is it has the geranyl at C3 in both Fleming key and Fleming A, and it's undergo cyclization with the hydroxy at C4. It's become the Pirano ring, and this Pirano actually play the important role for this compound to be active for as anti-cancer. If we compare to this similar, this is the oxyhomoflemingin, it has the geranyl group or geranyl chain on the C3 and as well as the hydroxy at C4. However, it doesn't undergo the cyclization. Hence, this compound, it does have any or it is inactive to the cancer cell. So the cyclizations is also play an important role for the activity of this compound. And as we know, the Fleming P, which doesn't has any geranyl, means that this Fleming P is inactive to the cancer cell. Next. Yeah. And from the Flemingia lineata, we also have got the prenylated, this is the prenylated flavon, actually. As we know that the number of isoprenyl attached to the flavon, it's also played as a role for their activities toward the cancer cell. As we know, for the flemilineatin A, actually, it has the 3 isoprenyl in it. And this is, if we compare to the 6 isoprenyl eridioxyol, it has only 1 isoprenylated in this in the chains in this ring, and then for the Fleming P, it has only 2 isoprenyl in the ring. So actually, it means that this isoprenyl play a role as a directed actually for the activity for anti-cancer. So even though the flaminiatin P has the 2 isoprenyl, whether the 6 isoprenyl erythritol only has 1, both of them are not active for the cancer cell. However, for the flaminiatin A, it has the 3 isoprenyl, with this one is actually what do you call drive the flavon to be active as an anti-cancer. Next, actually this two next please. Yes, this new compounds that we isolated from the Flamingia lineata as well as Flamingia macrophylla. Actually, we isolated through the simple procedure. We are using the traditional procedure from in our lab. So using we got it through the isolation. We use the maceration, and then we partition with normal hexane as well as the ethyl acetate, and then we fractionated through the column chromatography and then purified through the chromatotron. Through this simple procedure, actually we successfully got several pure compound and then a new compound. The thing that we use to introduce this, that the chromatotron is actually the very effective method that we use to get the pure compounds from the Flamingia lineata as well as the Flamingia macrophylla. Next. Actually, for this separation and then the purification, we use the various phase for various stationary phase, such as we use the silica gel, alumina, and Sepadex. The key of this separation, the key success of this separation is actually for this stationary phase that we use. So we combine in each step using the silica gel, alumina, or the Sepadex LH20. And then with the various eluent that we use. Based on this simple separation, actually, we find we got the several new compound from this Flamingia. Next. Yes, this is our research group. Actually, we involve the this is the area in the central of Kalimantan. We have the stationary farm there, or actually not stationary farm. Actually, that's stationary forest, because really we got it from the forest in central Kalimantan. And we collaborate with here Prof. Uco as well as Dr. Rate as our team on this research. And then we also involve the several students for this undergraduate as well as the master and doctor program. I think this is the thing that I can present to all of you. Thank you very much. And I give it to the master of ceremony.
Thank you, Professor Tejit, for the great sharing on this fantastic plant. Very beautiful. Not sure if I have seen it in Malaysia. I don't think so. Maybe it is native in Indonesia.
Yep. Yeah. Yeah. Actually, we caught it. This is native. That's why even now, I still wonder why we got this plant from the center of Kalimantan and also from East Java, which is this is different island.
I see. Okay.
Yeah.
Yeah, and then it has like a mix of color, pink color and green. Does it has other color?
Which one? Pink and green?
It, just now from the picture, I can see the color is around is like pink and green, right? Does it
Yeah,
has
yeah.
more colors
More for the color for the compound or the color for I'm
for
sorry.
the plant? For the plant, yeah.
Oh, for the plant. Oh, yeah, yeah. There are actually for the Macrophylla strobilifera, they have the color like very interesting because they have like the green and then turn to the orange. And but for the other Flaminia, it's only green and only green. They don't have any color.
I
Only
see.
for the
Okay.
Macrophylla strobilifera, they have very colorful.
I see. Okay. So thank you for your presentation. Okay.
Thank you.
Yeah. So now we come to the forum sessions for Q&A where we will get some questions from the floor. Okay. The first questions is addressed to Professor Prativi for the talk on uh, on the seaweed-based capsule. Okay. Professor Hisham from UTM asked about whether the carrageenan produced is pure kappa type or have some mixture of iota and lambda. If one of these present, how does it affect the hard capture quality? Okay.
Okay.
Yeah.
Thank you, Professor Hisam El Sassasi, for your question. The material base for capsule is pure kappa carrageenan because the iota carrageenan is from the Echima spinosum and kappa carrageenan from Echima cottoni. So it's different species. So it's not mixed. Yeah. And lambda carrageenan has three sulfate ions. So this is does not gel and is used only the secondary products. But the iota carrageenan has two sulfate ion. Kappa carrageenan has one sulfate ion. So that has affected the quality of the capsule. So because the ion sulfate will bind with another component, so carrageenan must be pure.
Professor Hisham, is that answering your question? Thank you.
Yeah.
We'll see if he's still with us. Okay, so it is a lot to do with the sulfate structures in that algae, right? Which is making it so hard than other gelatin, right?
Yeah.
And can you just now also in your talk, right? I remember you mentioned some about the gelatin produced, which is harder. Do you have any solutions how this problem can be solved for the future?
Yeah. I will mix the hydrolysis of the polysaccharide because the mass of the polysaccharide is very high. So this mass may be must be the degradation. So become the oligomer on a small molecule. The small molecule can be fast the release of the drug.
I see. Is it that you use some additive or you use a physical method to solve the hard problem?
Yeah. For gelatin, it's need preservative, but for the hard shell capsule, it's no need preservative.
I see. So it's more on the chemical method using the
Yeah,
preservative.
yeah.
Okay. Very interesting. And do you have any rough idea on the economic feasibility as compared to other gelatin sauce?
I don't
Mm.
I don't determine this the compare gelatin
I
and
see.
the hard shell
I
capsule from seaweed.
I see. I guess it will be a very good sauce because it can serve a large market for halal and also vegetarian market. Yeah. So
Yeah,
I think your product has a lot of good prospect. Okay.
yeah,
So okay. We will see if there is more question. Thank you for answering. Okay.
yeah. Thank you,
Yeah.
Professor Lee.
Okay. You're welcome. So we will. I'm checking the chat box if there are more questions for. Okay. Associate Professor Dr. Dayang. How may I know how you will think about extracting the pectin from the sweet potato peel? How about from potato peel? Is there any
Oh, yeah.
indications? Yeah.
Yes, potato peel has been extracted by many actually. Yeah, because it has also very high pectin. Yes.
Okay.
Yeah,
So
but I
both also
haven't done the but I didn't do the potato. I just do the sweet potato. But also interesting from what you asked just now, the economic analysis
yeah.
for this
Especially when you need another
construction.
enzyme to produce the
Mm,
pectin, right? So supposedly the cost
mm,
for the galactase is also quite high. So how do you
mm,
overcome this kind of material cost?
yeah, because as we know, the enzyme reaction we need it's actually quite high, right? The cost of enzyme. But I don't know if we can do like a combined reaction with acid first to open up the pectin structure, and then we can use this enzyme afterwards to synthesize this, hydrolyze this galactan to get this DOS. Yeah, probably we can, I don't know, further investigation on the reaction to reduce the cost, probably.
See, so this is
Mm-mm.
more like a exploratory stage
Mm-mm.
for this moment. Yeah. Okay.
Mm-mm.
So
Yep,
thank
yep.
you. I also saw Professor Tijit that you have to move to other sessions, right?
Yes, sorry.
Okay, I think it's okay. It's also already, we have already overrun the time by 15 minutes. I think it's all good. Maybe I will pass to the MC, Miss Julaiha, for the photo sessions. And thank you so much for all the speakers who are willing to share your valuable knowledge. Some of you also asked about attendance link. Yes, it is already here. Maybe the secretariat can paste the attendance link again at the chat box. I appreciate. Yeah, so I pass to Miss Dr. Julaiha now. Thank you. Yeah.
Thank you very much, Professor Dr. Lee Chuting, for sharing this session. On behalf of the local organizing committee, we would like to thank you to the speakers and viewers in today's session. I hope you found this to be informative and also very useful session. So, ladies and gentlemen, and now we would like to invite all the speakers and viewers to switch on the camera and use the I-Bes 2022 virtual background for the group photo session. So, technical and cameraman of the day, please get ready. Give your best smile on the camera. So, with a count, 1, 2, 3. One more. 1, 2, 3. Okay, thank you very much.
you.
So, ladies and gentlemen, please return to the end of the session and see you again in the afternoon for the fourth session of Symposium. We are going to start again at 2 p.m. Malaysian time. Thank you and see you again. Assalamualaikum warahmatullahi wabarakatuh and good afternoon to all speakers and viewers. Thank you for staying tuned with us in this virtual international symposium on biomedical, biorefinery and energy security I-Bes 2022. You may also follow us through our DVCRI YouTube. My name is Zulaiha and as your moderator today. Welcome to the first session of this symposium on the topic of biorefinery and biotechnology. Ladies and gentlemen, before we begin, I want to highlight a few important points for our event today. Please take a look at your chat box. In the chat box, you may find the program kit, which includes the guideline for the WebEx meeting, program book, and also the virtual background. Be sure to complete the attendance form using the link provided in the chat box. So, ladies and gentlemen, this evening we are so delighted to have our expert as our session chair, Dr. Nur Izan Wan Azli, and allow me to introduce her to all of you. Dr. Nur Izan Wan Azli is an associate research fellow in Institute of Bioproduct Development (IBD), and she has obtained her bachelor degree as well as completed her PhD in bioprocess engineering from Universiti Teknologi Malaysia. Her research expertise is on enzyme technology, enzyme immobilization, carbohydrate analysis, biomass pretreatment, biomass conversion, process optimization, and enzyme kinetics. Currently, she is working on pretreatment of biomass for efficient delignification, enzymatic hydrolysis, and optimization for high sugar production, enzyme immobilization for trans-esterification for biodiesel productions. Dr. Nur Izan, the floor is in your hands.
Okay, Assalamualaikum and good afternoon, everyone. Welcome back to our session for today, this afternoon, entitled Biorefinery and Biotechnology. Okay, so our session would begin with the fourth plenary speaker by Associate Professor in Senior Technologist Dr. Roshanida Abdul Rahman, with her title Conversion of Biomass into Value-Added Products. Okay, before we proceed, before I pass to Associate Professor Dr. Roshanida, let me introduce a little bit of her background. Okay, Dr. Roshanida Abdul Rahman is an associate professor at the Faculty of Engineering, Universiti Teknologi Malaysia. She has been serving as an academician in the chemical engineering field for more than 20 years. She is also a member of the Institution of Chemical Engineers and a chartered engineer of the UK Engineering Council, as well as a professional engineer under the Board of Engineers Malaysia. Her research interest is in the area of bioprocess engineering, specifically in environmental biotechnology, enzyme technology, and bioconversion process, and has published more than 100 publications in reputable journals and other platforms. Okay, without further ado, I pass the microphone to our fourth plenary speaker, Associate Professor Dr. Roshanida Abdul Rahman. Please welcome.
Thank you to the chairperson, Dr. Izian. So let me share first. Okay. Assalamualaikum warahmatullahi wabarakatuh and good afternoon to the respected colleague and audience. I am Roshanida from Universiti Teknologi Malaysia and will be presenting. Title for today is Conversion of Biomass, particularly lignocellulosic biomass into value-added products. A little bit on the introduction. Lignocellulosic biomass has been known as a potential renewable and inexpensive energy source because of the abundant material in most countries, especially in Asia. We can see a large amount of lignocellulose generated through forestry, agriculture, and also agro-industries. It's categorized as waste that cause environmental pollution problems because of the considerable accumulation in nature. Therefore, the utilization of this lignocellulose is beneficial for producing value-added products and solving environmental issues. Lignocellulosic biomass can be utilized as a substrate to produce various value-added products such as biofuel, food additives, vitamins, animal feeds, and also amino acid. In general, lignocellulosic biomass is mainly composed of three significant polymers, which are cellulose, hemicellulose, and lignin. The major source of lignocellulosic biomass is agricultural waste, such as rice straw, wheat straw, wood or hardwood, byproduct left over from the corn milling process, corn fiber, waste paper, and so on and so forth. Okay, in the bioconversion process, there are a few important steps or processes in order to convert lignocellulosic biomass into the optimum value-added products, which are pretreatment, hydrolysis, and also fermentation in the product conversion process. So I would like to introduce a little bit on the pretreatment process, which is the most important step in lignocellulosic biomass processing, where carbohydrate polymers are converted into simple sugar before fermentation. Due to the heterogeneous and complex nature of the lignocellulosic biomass, enzymatic hydrolysis is not an efficient method for native biomass. Hence, this biomass need to be pre-treated first to be amendable to any enzyme reaction. In general, there are four different pretreatment methods, which are physical, chemical, physicochemical, and also biological. Among these pretreatment, chemical pretreatments are demonstrated to modify the chemical structures of the lignocellulose effectively. However, using chemicals in pretreatment, such as and also the neutralization and also fermentation conditioning, should be minimal and cheap. As for now, acid pretreatment involves utilizing acids such as sulfuric acid, nitric, or hydrochloric acid to remove hemicellulose and expose the cellulose to the enzymatic hydrolysis. As for the part of hydrolysis process, this process is aimed to convert the polysaccharide into fermentable sugar. There are three types of hydrolysis, which are acid hydrolysis, microbial hydrolysis, and also enzymatic hydrolysis. However, some researchers reported that acid hydrolysis has a few drawbacks, including the production of degradation product, while enzymatic hydrolysis by using cellulase, for example, does not generate any inhibitor, and the types of the enzymes were very specific to hydrolyze cellulose polymer into its monomer. Hydrolysis by using enzyme, we can say that is the most promising method due to less pollution, less byproduct formation, and producing high yield compared to acid hydrolysis and also microbial hydrolysis. And the last part is the fermentation process, which is a metabolic process involving microorganisms to break down molecules such as glucose into value-added product. We can have like alcohol or acid. Fungi, yeast, and bacteria are commonly expressed and secrete various enzymes involved in the degradation and recycling of complex biopolymers. On the other hand, Aspergillus niger was exploited primarily in the food industry, and it is generally regarded as safe. One example in the pectin and pectinase industry, application and preparation fungus have mostly been obtained from Aspergillus niger. Besides that, methods of fermentation such as solid state fermentation, submerged fermentation are important for the production of microbial enzymes. In some cases, solid state fermentation is the most suitable fermentation techniques involving fungi and microorganisms that require low moisture content. Okay, therefore, I would like to share a few research studies that have been done in my lab with my team on the conversion of lignocellulosic biomass into different products. The first study was on the optimization of pretreatment and enzymatic hydrolysis of oil palm fronds for xylo-oligosaccharides production. As we know, oil palm biomass is one of the most potential lignocellulose biomass that can be utilized to produce xylose. Most of the time, the wastes are usually left to rot or burn in the field after harvesting. So this study aims to produce xylo-oligosaccharides or XOS through enzymatic hydrolysis with optimized process conditions using pre-treated oil palm fronds. The methods involve several processes such as sample preparation of the oil palm fronds, the pretreatment of the oil palm fronds that involve acid, alkaline, and also auto-hydrolysis. And finally, the enzymatic hydrolysis by enzylanase to produce the XOS and also other reducing sugars. Okay, in this slide, we can see the lignocellulose content of fresh OPF or oil palm fronds, and also the pre-treated oil palm fronds using auto-hydrolysis, acid hydrolysis, and also alkaline hydrolysis. So in order to determine its hemicellulose content without any pretreatment, we can compare with this pre-treated OPM. So we can see the difference, the structure that appeared from the fresh OPF compared to OPF with the pretreatment. It offers rigid, you can see from the first figure, rigid, organized, and highly ordered fibers from fresh OPF, while the alkaline pretreated or pretreatment shows fully distorted and damaged biomass and irregular crack structure. It shows that pretreatment successfully altered the biomass structure and made it more efficient for the enzymatic hydrolysis process afterwards. Okay. And also this figure shows the production of reducing sugar from OPF after the enzymatic hydrolysis using different pretreated OPF methods just now. It shows that an OPF with an alkaline pretreatment methods produces a comparably high reducing sugar, which is around 73% higher than acid and auto-hydrolysis pretreatment methods. It shows that an effective and optimized pretreatment process enhances the enzymatic hydrolysis process, thus enhancing the production of reducing sugar as well as the XOS. However, we have to bear in mind that the effectiveness of alkaline pretreatment is actually dependent on the physical structure and also the chemical composition of the biomass as well as the treatment conditions. In general, alkaline pretreatment is more efficient on hardwood, herbaceous crops, and agriculture residues, which have a lower lignin content than softwood, which contain high amounts of lignin. Okay, this is the second study that I would like to introduce or share. This is about the optimization of pretreatment and enzymatic hydrolysis of pineapple leaf fiber for reducing sugar production. So this pineapple leaf fiber or PALF is one of the abundant biofiber products from pineapple cultivation, which is widely grown in Malaysia and Asia. It has been reported that this pineapple leaf fiber consists around 70 to 82% weight per weight cellulose content, which is higher than other raw materials such as barley straw, corn cobs, and also wheat straw. Therefore, this fiber can produce a high yield of reducing sugar and become a new source, thus replacing the non-renewable and expensive raw material in many industries. However, to achieve the high yield of reducing sugar again, an ideal pretreatment process is required to enhance the accessibility of enzymes to convert the polymer into simple sugar via the enzymatic hydrolysis process. So throughout this study, different pretreatment methods were conducted to investigate the ideal pretreatment methods for pineapple leaf fiber, and also the operating condition of the ideal pretreatment was also optimized to obtain the optimum reducing sugar yield. Okay, these figures, for figure A, it shows that a fresh PALF or the pineapple leaf fiber has a rigid and highly ordered fibril structure, surface structure, while figure D shows that the lignin compound in alkaline pretreatment was dissolved and the internal cellular structure was exposed compared to figure B for auto-hydrolysis and figure C for dilute acid. The development of cracks in alkaline pretreatment for this PALF had increased the available surface area to enhance the penetration of cellulase enzyme into cellulose during hydrolysis, thus enhancing the yield of reducing sugar, while fresh PLF clearly shows a minimum surface area, making it an obstacle for the enzyme to penetrate the cellulose. Okay, while this figure shows that the alkaline pretreatment produces an optimum total reducing sugar production compared to acid and autohydrolysis, pretreatment by sodium hydroxide removes the partial lignin in the lignocellulosic biomass by softening and rupturing the cell wall to fracture the ester bond and decrease the crystallinity of the cellulose, while dilute sulfuric acid pretreatment did not significantly solubilize enough lignin to produce maximum reducing sugar. As we can see, the autohydrolysis pretreatment removed only a small amount of lignin but did change the lignin structure to enhance the accessibility of the enzyme. It shows that the alkaline completely dissolve lignin and make it easier for enzyme cellulase to penetrate into cellulose to hydrolyze carbohydrate into total reducing sugar. And another study that I would like to share today is the production of exopolygalacturase by Aspergillus niger with pectin extract and the substrate from Nephrolipis becerate leaves or fern in solid state fermentation. So pectinase is one of the commercial enzymes on the market and serve to decompose pectin, a type of polysaccharide substrate contained within the cell wall of a plant. This enzyme breaks the polygalacturonic acid into monogalacturonic acid by opening the glycosidic linkages. Pectinase generally hydrolyzes the pectic material depending on its capability for using the substrate, whether pectin or pectic acid, as well as its operating mechanism. Meanwhile, pectinase is produced by various types of microorganisms that use pectin as a carbon source. Various agricultural and also agro-industrial waste have been utilized as carbon source to stimulate the production of pectinase by microorganisms. So in this study, the activity of exopolygalacturonase produced by Aspergillus niger was obtained in solid state fermentation using this fern leaf or Nephrolipis becerate leaves as a substrate. The methodology involves sample preparation, pectin extraction, and then solid state fermentation, as well as optimization process, and lastly, production of exopolygalacturonase. For selecting the best pretreatment for this process, this result shows that autohydrolysis compared to the previous two processes or two studies just now, from this study, it shows that autohydrolysis is the optimum process to alter the physical structure of the leaves, the fern leaves, compared to the other pretreatment method studied. In industrial research and technology, the advantage of autohydrolysis include the ability to hydrolyze more hemicellulose and the reduction in the complexity of cell wall components by degradation. During the autohydrolysis process, water vapor rapidly escapes from inside and also between cells, thus destroying cell walls and tissue connections. So in this study, higher exopolygalacturonase activity by Aspergillus niger was found with autohydrolysis pretreatment. The activity was around 39 unit per gram, and also the biomass of the niger was around 0.38 milligram after 120 hours. So pretreatment of the leaves is important to enhance and accelerate the exopolygalacturonase substrate fraction to obtain the products. So this is another study or the last study that I would like to share today that has been conducted in our lab regarding biomass conversion, which is slightly different from the previous three studies that I've shared. This is about the characterization of fabricated mycelium-based biofoam from biomass. Mycelium-based biofoam has been known as a sustainable alternative to the petroleum-based polymeric material. It is fabricated by inoculating fungal strain in the substrate, and the fungal degrades the substrate as a feeding element to extend its hyphae while branching new hyphae and fuse together to form a denser network. the colonization of this mycelium on the substrate is able to cement itself strongly. So the result is a lightweight and biodegradable composite with a low environmental impact, thus able to replace fossil-based and synthetic materials such as polyurethane and also polystyrene. So in the production of the mycelium bioform, the cultivation of fungi mycelium is in the solid state fermentation. So in this study, the objective is to determine the effect of fungi growth factors in the solid state fermentation, which are temperature, inoculum weight, and moisture content towards the mycelium growth on different biomass, such as we have studied on the rice husk, sawdust, and also sugarcane bagasse. So these are some of the findings from this study. It proves that the conversion of lignocellulosic biomass not only can produce food and beverages and also ethanol, but it can also produce material with a mechanical strength, thus having potential properties to replace petroleum-based polymeric material. Yeah. So as a conclusion, this bioconversion of lignocellulosic material has shown a different biomass property with variation products. The pretreatment, such as hydrolysis and also fermentation process, gives valuable input for current and future renewable sources of the industrial raw materials. In the meantime, the utilization of lignocellulosic biomass could be an alternative material for the production of value-added product that heavily relies on the fossil resources. With that, I thank you for your attention. Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Rosalinda, for the brilliant sharing on your current work, on your current and also your students' work. And Dr. Rosalinda has greatly wrapped up all the findings that she has by valorizing the biomass from the OPF, the so-called leaves, and also from the mycelium or the mushroom, to valorize it into several value-added products such as reducing sugar, pectin, the enzyme which is the exopolygalacturonase, and also for the biofoam from the mushroom mycelium is for the application of biophilus and many more. Thank you very much, Dr. Associate Professor Dr. Roshanida. Okay, let us continue with our invited speakers. Okay, in this session, we will have 6 invited speakers, which will be starting with Professor Dr. Junaidi Khatib, and then secondly goes to Dr. Rosnani Hasham, and then goes to Associate Professor Dr. Laura Navika. And then after the third speaker, we will have a short break around 5 minutes before we continue with the fourth invited speaker, Dr. Abdul Fattah Abdul Samad, Dr. Satya Chandra Wibaya Sakti, and last but not least, Dr. Cheng Kian Kai. Okay, so without further ado, before we start with our first invited speaker for this afternoon session, let me introduce a little bit on Professor Dr. Junaidi Khatib. Khatib is a professor at the Faculty of Pharmacy, Universitas Air with expertise in biopharmaceuticals. He completed his Bachelor of Pharmacy, professional program and master's program at Universitas Air. His doctoral program was completed at Hoshi University School of Pharmacy and Pharmaceutical Sciences, Japan in 2004. Currently, he is a lecturer in the Department of Practical Pharmacy, Faculty of Pharmacy. He is active in carrying out his research, which includes the development of biomolecular drugs, evaluation of drug effectiveness, and bioequivalence of drug products. Prof. Khatib has received various research grants from the Ministries of Education, Culture, Research and Technology, as well as the pharmaceutical industry, both national and multinational. In addition, he is also a member of the expert team in the field of standardization of medicinal products at the National Food and Drug Agency. Until now, it is still recorded to provide consultation on the development of drug products in the pharmaceutical industry in Indonesia, Japan, and also Korea. In 2010, he was appointed as Deputy Dean for Human Resources and Finance at the Faculty of Pharmacy. And in 2015 until 2020, he was trusted to be the Vice Rector for Business Development and Alumni Networks, Universitas Air Langga. Since 2020 until now, he has served as the Dean of the Faculty of Pharmacy, Universitas Air Langga. Without further ado, I welcome Professor Khatib to deliver his speech. The floor is yours, Professor Khatib.
Okay, thank you, Dr. Nur Isyan.
You're welcome.
Can I share?
Yes, you may start to share your slide. Yeah. Okay, now I can see your slide.
Okay.
Yes, just make it a slideshow.
Okay.
Yeah.
Okay. You can watch the PPT, our PPT.
Yes, very clear, Prof.
Okay.
You may start. Yes.
Okay. Assalamualaikum warahmatullahi wabarakatuh, and good afternoon for everyone. First of all, I would like to thank the scientific committee of the International Symposium of the Biomedical, Biorefinery and Energy Security for giving me chance to share our research nano-engineer bovine hydroxyapatite targeted osteogenic cellular maturation in development of osteoinductive scaffold. This theme concerns on the two aspects, biomaterials and engineering biotechnology. So in this symposium session, I will convey toward biotechnology. Meanwhile, another colleges had conveyed the biomaterial aspect in the yesterday session. This research will already carried in Air Langga University and Seoul National University. And now, why do we focus the research on the area of bone defect and effort to address them properly? As we know together that the bone defect is a neglected disease. This disease also affects the quality of life and the patient economic burden. Further, every year, over than 2.2 million people globally undergo bone grafting procedure to treat bone defect. So there are need development of osteoconductive biomaterial for bone tissue engineering to accelerate bone defect repair. We also focus on the natural bovine hydroxyapatite because hydroxyapatite is widely used biomaterial as a bone graft. I think many reference or several publications such as on the screen by another group and also our group in biomaterial also did this research. And the use of material can repair and overcome the problem of bone defect, either synthetically or natural of the hydroxyapatite. Second thing is advances of nanotechnology bring several benefits, of course, cannot be sparedly from the risk opportunities that occur. However, our study and several reports have shown that the improvement in implant perform when using material with particle size engineering, they are going improve. Several explanations have been given because in a small size of the particle, they will have a large surface area, more compatible with hydroxyapatite present on the bone, and also the last our publication, we have predict that the hydroxyapatite as a ligand can bind with the osteoblast receptor. So that the development of the nanoscale material has been rapidly increasing in the last decade. Nanoscale biomaterial has been reported to have beneficial effect in the bone tissue engineering, such as increasing adhesion, differentiation, and proliferation of osteoblasts, and providing vascularization and bone formation uh, uh, in vivo in animal model or human. However, the effect of nanomaterial, particularly in osteoclasts, was not expected as like in osteoblasts. And the third, we know that the phases in bone defect healing following as like shown in this slide, so that the healing process for bone defect goes through several stages, namely inflammation, reparative, and remodeling. The three stages require biomaterial to accelerate the inflammatory process for getting the shortly recovery. And the next step is repair, involve the change from the mesenchymal stem cell to pre-osteoblast. And the last, of course, osteoblast will differentiate and have a function. Based on our study, each step is strongly influenced by the presence of hydroxyapatite material that can bind directly to a specific protein in the osteoblast. And then, considering this beneficial effect of the biomaterial in the bone tissue engineering for development of the bovine or natural hydroxyapatite in the form either submicron or micron scale is indicated to increase its osteoinductive and osteoconductive properties. So that our research that is to examine the nano-engineered bovine hydroxyapatite targeted osteogenic cellular maturation in the development of the osteoinductive scaffold. So that we divide into three steps in this research. The first is synthesis and fabrication of nano bovine hydroxyapatite by using dry milling method or wet milling method. I didn't talk much about the dry milling method because there are already published in Materials 2022. And small thing, we will talk about a wet milling method and then continue to the in vitro study by the using osteoblasts to find out the optimal growing condition of the osteoblasts and how to improve, increasing the differentiation and activity of the osteoblast, and the last, of course, signaling pathway of the osteoblast. And the last part, in vivo studies in the animal model, but today I think we have limited time, so that I will talk one and two only. Maybe another a chance I will share about the in vivo study in animal model for using nano hydroxyapatite in bone defect on animal model. Our research showed that the we have identified and characterized the natural hydroxyapatite and synthetic hydroxyapatite using various approaches, ranging from the particle shape, size of distribution, proportion of the calcium, phosphate, and carbonate, and also polydispersion index. we found that the hydroxyapatite and also bovine hydroxyapatite have the good characteristic uh, uh, for the biomaterial can use as a implant on a bone filler. The size originally is a micron, and we changed using the several methods to find out the nano size of the material. And the next slide we engineer the particle size of the bovine hydroxyapatite and hydroxy by various methods. And this slide show by wet milling method, either lab and pilot scale. We did both in our laboratorium. We found that the wet milling method resulted in the more homogeneous size of the particle, very stable particle, and lower agglomeration rate based on the several tests as like SAM EDX, FDIR, XRD, and particle size analyzer DELSA Nano for approach this characteristic. This slide shows that the morphology of the nano bovine hydroxyapatite observed by SAM and TEM, both they have a similar particle size using the wet milling method. That is closely with 50 nanometer for higher in distribution. And then we continue to describe more detail of the morphology and qualitative particle size comparison between nano bovine hydroxyapatite, bovine hydroxyapatite micron, nano hydroxyapatite, and also hydroxyapatite. And our data showed that nano bovine hydroxyapatite and bovine hydroxyapatite, they have a shape more like hexagon shape, while nano hydroxyapatite and hydroxyapatite is irregular form. And nano bovine hydroxyapatite and nano hydroxyapatite were smaller compared to the bovine hydroxyapatite and hydroxyapatite respectively, as shown in this figure. Physically and chemical characteristic of also we did, and there are no change the all of the process to change the size of the particle. They didn't change the size characteristic of the material. And particle size stability and agglomeration potential were also evaluated. This slide shows the hydrodynamic particle size and polydispersity index of the nano bovine hydroxyapatite until 72 hours after fabrication. And I think we now have data about this stability until 3 months and 6 months. There are shown that the nano bovine hydroxyapatite particle size were stable after fabrication. This slide shows the size of nano bovine hydroxyapatite was nano size, both deionized water and grew medium. So that if we take a look this data, so that the size of this particle that is stable in a deionized water or crew medium. So that is applicable for do some experiment in cell culture. And then on the third step, we do the cytotoxicity, the nano bovine hydroxyapatite in the MC3 T3 E1 cells. And that is, of course, we following the standard method as like in this slide. And the results show that you can be seen in this slide. So that hydroxyapatite is a material that induces the most cell death, but not for bovine hydroxyapatite or natural hydroxyapatite. And we also do some research to evaluate the viability of the cell, of course the same MC3T3E1 cells. And we also receive the data that viability test so that the cell could grow well after exposure to nano bovine hydroxyapatite. And as shown this data that ratio live and dead cell viability assay of the MC3T3E1 cells in different condition shown in this figure in day 4, day 7, in day 15. We can see that nano bovine hydroxyapatite there are induced the proliferation and deviation much large than others biomaterials. That is indicate that the nano bovine hydroxyapatite the good proper characteristic of the material can use for the bioimplant. And we also check the.
Sorry, Prof, for interrupting. You
Okay,
have another
the time
2
is
minutes.
okay. Okay.
Okay.
We also check the a specific protein, and we have data that this protein bovine hydroxyapatite in nanoscale induce the differentiation. And we also staining in using the ALP, and we know that nano bovine hydroxyapatite induce accelerate the differentiate in day 7 if compared with other. Of course, this situation will give benefit for this biomaterial. That is also the differentiation acceleration by the nano bovine hydroxyapatite. We also check another protein marker, and we conclude that the synthesis and manufacture of the nano bovine hydroxyapatite to produce stable and nano size using wet milling method. Nano bovine hydroxyapatite increase pre-osteoblast proliferation compared with the hydroxyapatite. Nano bovine hydroxyapatite accelerate differentiation pre-osteoblast to mature osteoblast. And the last mature osteoblast has the ability to proliferate induced by the nano bovine hydroxyapatite. I think enough for my presentation, and thank you for your attention.
Thank you very much, Professor Khatib, for the very sharp presentation according to the schedule. Okay, so for those who wish to ask Professor Khatib regarding his presentation, you may write your question in the chat box also, so that we can discuss it in the forum during the forum. Okay, so let us thank you again, Professor Khatib. So let us continue with our next invited speaker, Dr. Rosnani Hasham. Okay, Dr. Rosnani Hasham, you may share your slide. Okay, Dr. Rosnani, are you here?
Yes.
Okay, you may
Can
share
you
your
hear me?
slide. Yes,
Okay.
very clear.
All
Okay,
right.
so before, okay, you may share your slide, Dr. Rosnani. Okay, while
Okay.
waiting for Dr. Rosnani to share her slide,
Mhm.
let me introduce a little bit on Dr. Rosnani background. Dr. Rosnani has been with Universiti Teknologi Malaysia for almost 20 years. She has dedicated her research career to a broad range of areas, including skin molecular biology, novel ingredients discovery and formulation, pharmacological evaluation, as well as wellness and aromatherapy consultant and trainer. Dr. Rosnani is an active researcher and passionate in exploring and studying Malaysian indigenous plants as a potent source of medicinal or cosmeceuticals through the identification of its bioactive components. Her expertise also involves the inclusion of research and applications of nanomaterials, transdermal and controlled release evaluation. There are several recognitions and awards have been granted to Dr. Rosnani, including Industry Involvement Award in 2021 at Staff Excellence Award Ceremony, UTM. Global Medal Award in 2020 at SIIF South Korea, and the Most Innovative Award in 2016, and Biotechnological Innovation of the Year Award in 2013 at Bioinnovative Awards Malaysia. Okay, so without delaying any time anymore, I pass the microphone to you, Dr. Rosnani. The floor
Okay.
is
Thank you so much, Madam Chairman.
You're welcome.
Okay. Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon to all. So first of all, I would like to thank the organizing committee for inviting me to share our research output in this symposium. So today I would like to share the several of our research on the wound care management through biorefinery principles. So the outline of my presentation, first I will talk about the wound healing mechanism, and then principles of wound care management through biorefinery, phytoconstituents for wound healing, and several case studies and conclusion. So, okay, for the introduction on the wound healing mechanism, as we know that wound healing refers to the replacement of destroyed or damaged tissue by newly produced tissue. So, in undamaged skin, our skin consists of two layers, the epidermis and dermis layer. So, the epidermis and dermis layer form a protective barrier against the external environment. So when the barrier is broken by the injury, so a regulated sequence of biochemical events is set into motion to repair the damage. So the process is divided into predictable phases. So we can see here in this picture, you can see that the homeostasis, inflammatory phase, proliferative phase, remodeling, and then heal tissue. So in the homeostasis, it will consist of vasoconstriction, platelet aggregation, leukocyte migration, and then during the inflammatory phase, hours to days. So it's involved the early neutrophil, chemoattractant release, late macrophages, phagocytosis, and removal of foreign body bacteria. And then in proliferative phase or tissue growth, the fibroblasts in our dermis layer will proliferate and collagen synthesis will produce extracellular matrix reorganization, angiogenesis, granulation, tissue formation, and epithelialization. And then the remodeling involves epithelialization, extracellular matrix modeling, increase in tensile strength of wounds, and then heal tissue. So the importance of proper wound care. So as you can see here, the proper wound care, it could encourage the wound healing in shorter time. So the proper care could help in bacterial clearance, cytotoxicity, tissue necrosis, apoptosis, phagocytosis, and then during the inflammation, it helps the inflammatory resolution, tissue debris removal, and then the proliferation, it helps the re-epithelialization and ECM remodeling. So, however, in poor healing condition, there are several conditions that cause severe damage to infected area and other skin problem, especially during aging, because of aging, because of the infection, and then because of the metabolic diseases such as diabetes. So in this figure, you can see that the common in elderly, they call it as venous leg ulcer. And then in diabetic foot ulcer, they have the infection and foot deformities. And then the hypertrophic scar, it will caused by rapid growth, generally regress less than 6 months. And then the collagen fibers parallel to skin surface and vertically oriented blood vessels. So we can see that the scar is very obviously shown in our skin. So that's why in this study, we try to share the role of bioactives on accelerating the wound healing. As we know that in Malaysia, in Indonesia, in our Nusantara area is very, we have a lot of plant, indigenous plant, various plant products have been used to treat the wound over the years. So wound healing herbal extracts, for example, could promote the blood clotting, fight infection, and accelerate the healing of wounds. So the phytoconstituents derived from these plants needs to be identified and screened for their activities in management of wounds. For instance, we have the polyphenols, flavonoids, alkaloids, and other materials that benefit to the wound healing. For example, these plants can act as painkillers, anti-inflammatory agents, topical antimicrobial agent, helps to promoting the healing and also extracellular matrix. And also after this phenomena, it can shorten the time possible and then minimal pain, discomfort, and also conducive in tissue repair and regeneration. So other than that, we also have the alternative on the wound dressing. So this wound dressing can incorporate in the bioactive and can accelerate the wound healing. So as you can see here, in this study, they incorporate the actives in the hydrogel and also the hybrid patch of the nano generator. So in this study, you can see in this figure that the hydrogel incorporated bioactive and also the hybrid patch, the healing is shorter time compared to the control. So it's amazing and helps the healing very good and in shorter time. So the dressing has been designed to target and not only on the kill infection causing bacteria, it also can promote the moisture retentive dressings. So in this, in our study, we will show you how the moisture content is very important in our skin remodeling. So this is the examples of wound dressing. As you can see here, in the case of the superficial disruption of skin, phlegms and then the PMDs such as the tegaderm, polyskin is very good for the wound dressing. And then for the fibrinous wound, we can use the protease, and then the granulating epithelializing wounds, we can use the hydrogels, hydrocolloids. In exudative skin, we can use the alginate, hydrofibers forms, and then in scar wound, we can use the hydrogels, hydrocolloids. So that's why from this evidence, we would like to suggest the environmental sustainability using our plants waste and also the bioactives from our plants, and then we can use in the concept of biorefinery to produce the wound care management. So environmental sustainability has nowadays become an imperative issue to France. So in an effort to balance both the industrial productivity and the planet ability to generate resources with the neutralization of waste and mitigation of polluting processes. So nature itself can be inspiration to develop cost competitive, low energy consumption and fully biodegradable materials, presenting greater environmental sustainability. For example, like naturally derived biopolymers also provide a versatile, multifunctional and tunable platform to design appropriate extracellular environment, able to actively contrast the onset of infection and inflammation while promoting tissue regeneration and scar remodeling. So in Malaysia is located in a region where biomass productivity is high, which means that the country can capitalize on this renewable energy resource to supplement limited petroleum and coal reserve. So Malaysia, as a major player in palm oil and also other woods, rice hulls, sugarcane, produce a substantial amounts of agricultural biomass waste, which present a great opportunity for harnessing biomass energy in an eco-friendly, commercial manner. So in this study, the plant-based waste from the food processing, agriculture, retail are generated in large quantities. So these waste have the potential to offer a wide range of valuable compounds. They are usually rich in lignocellulose, hemicellulose, xylose, glucose, and then other therapeutic compounds including phytochemicals such as fats, waxes, proteins, and we have the glycosides, saponins, fatty acids, flavonols. So these phytochemicals have immense potential for the management of skin disease. So the phytochemical activities such as antimicrobial, antioxidant, anti-inflammatory, these activities encourage fight infection, accelerate wound healing and scar management, while the lignocellulose-based materials have high potential in biomedicine, especially for drug encapsulation, release such as scaffolds, for regeneration in wound healing and therapies. So the porous structure can influence materials geometry, density, surface area, permeability, and absorption capacity. Therefore, it is suitable for some medical use. So the application of plant waste not only for the biocomposite electronic foods, but nowadays we can use as cosmetics, as pharmaceutical, and also as medical properties. So we believe that this biorefinery can turning the waste into a win in wound healing properties. So this is the schematic illustration of practices in wound healing studies of plants. If you have the waste plants, and then how you can produce products from it. So for example, like you can extract the phytochemical compound from the plant waste, and then you can proceed with the in vitro study, or we call it as preclinical, and then development of formulation. You develop from the in vitro study the potential of the extractive materials. You can develop a formulation, and then further to the in vivo study, and then you can design also the drug administration study, whether you want to make it into nano-engineered materials, or you can incorporate into several materials for the advanced formulation, and then you can do the analysis. So this is phytoconstituents from plants and their wound healing properties. As you can see here, we have the phase 1, phase 2, and phase 3. The homeostasis, usually homeostasis and inflammation usually in one phase. So our famous herbs, the curcuma longa, have bioactive like phenols, and these phenols is very good for the homeostasis decreases, homeostasis, decreases in aggregation of neutrophils and analgesic and infection control. While for the remodeling, they're also good in collagen synthesis and also the granulation tissue. So I would like to share with you our case study, the standardized processing method for Ficus Deuterdia fractionated extract. This plant in our region, we call it as mascote. So this plant is very special. So we extract the plants for the jamu, for the traditional concoction. So and then we focus on the vitamin-rich extracts. So from the Ficus deuteria extract, we found that it's very good for skin barrier activities. As you can see here, that it can promote the cell regeneration and then inhibit the hyperpigmentation, meaning that you can promote less scar effects on the wound. And then it shows the very good anti-inflammatory and then wound healing activity. So this one is the activity of wound healing compared to ascorbic acid. Control and ascorbic acid. Ficus deuteria extracts shows very good and strong anti-aging and also wound healing activity compared to the control. And also it promotes the collagen synthesis in the in vitro study. So furthermore, we proceed with the activity of hydration, the potential of hydration of the Ficus deuteria, because as I mentioned before, that hydration is also important in the tissue remodeling and also anti-inflammation. So in this study, we found that Ficus deuteria was able to induce the keratinocyte differentiation markers protein such as involucrin and also transglutaminase. These two markers is very important markers for the chronocyte envelope development. You know that the in our stratum corneum we have the chronocyte and then we have the envelope of the chronocyte. Inside the chronocyte is the natural moisturizing factor and the outside is the intercellular lipid. So and then this plant extract also promote the natural moisturizing factor generation and also promote the intercellular lipid processing, meaning that it can promote the process of the protection layer of the stratum corneum. And then we further develop the nanostructured lipid system of the ficus using the lipid nanoparticles. So from this study, you can see that from the nano encapsulation, it promotes it accelerates the permeation compared to the FD extract itself. And then you can see after 12 hours, this NLC Ficus deuteria can penetrate to our dermis compared to the control after 12 hours. So it's very fast. And then we further with the human study. So from this study, you can see that the NLCFD, when we apply to the skin, it can accelerate the skin barrier recovery up to 80% within 24 hours compared to the base cream and control. And then from the in vivo study, we can see that it increased the hydration level in the skin and also reduce the irritation caused by the skin disruption of the skin. And then it's also promote the ceramide. Ceramide is one of the lipid component that is important in our skins that promote the wound healing. So in this study, we shows that the NLC Ficus deuteria can promote higher ceramide content compared to the before the treatment sample. So we believe that the formation of effective moisture skin barrier from these products can help in the skin restore of the disrupted skin by moisturize, anti-inflammatory and repair and rebuild skin. So furthermore, this is our study led by Associate Professor of Dr. Nadia Adros. This study is rice straw fiber cellulose hydrogel. So she extracts the cellulose, optimize of natrium hydroxide composition, and then prepare of cellulose solution and prepare of hydrogel and characterization study. So the aim of this study is to evaluate the optimum sodium hydroxide concentration for the extraction of cellulose from the agriculture waste. In this study, we investigate the rice straw fiber towards preparation of cellulose-based hydrogel. You can see here, this is the physical appearance after pre-treatment. So this is the 6% of bleached rice straw. So after the extraction, the cellulose was firstly dissolved in the dimethyl acetamide lithium chloride, and the hydrogel was regenerated via phase inversion in ethanol. So you can see this is the hydrogel patch. So the increase in weight loss in 6% of natrium hydroxide, the increase in weight loss with the increasing alkaline concentration suggested that the lignification took place progressively up to 6% of natrium hydroxide, and as supported by reduction in color intensity of the fiber and also the chemical analysis by the FTIR. And then this one is the equilibrium swelling ratio and gel fraction, tensile strength and elongation at break. So the highest swelling, gel fraction, tensile strength and elongation at break were also found for hydrogel when regenerated from cellulose treated with 6% of NaOH. And this study verifies that 6% of NaOH is the optimum concentration for cellulose extraction that enhance the key aspects of good properties of cellulose hydrogel from the rice straw. So the uniqueness findings of this study is the swelling ratio and EB increase. Yes?
Sorry for interrupting.
5 minutes.
You have, yeah.
Okay. Noted.
4 minutes.
Okay.
Okay.
All right. So the uniqueness findings of this study is the swelling ratio and the increase, although the gel fraction and tensile strength also increases. So ultimately, extraction of the cellulose from waste to produce hydrogels may have novel impact for solving underutilized biomass. Okay. So lastly is the case study of the transdermal diffusion test where we incorporated the bioactive in a patch. So this study, we collaborate with the International Islamic University in Kuala Lumpur, led by Dr. Fatila Ali. So in this study, we investigate our patch with the bioactive by using the skin diffusion method. So in this membrane, the membrane is mimic our epidermis, our skin layer, So this is non-invasive method. So from this study, you can see that this is the blank patch, and then this the bioactive without patch, and this is the patch. The objective of this study is we want to evaluate whether the patch that we develop can hold the bioactive and also able to penetrate to our skin. Because as you know that, as I mentioned before, that wound dressing is also important to make sure that the accelerated of the wound healing. So you can see here, the patch with bioactive can slow down the penetration, meaning that control release of the materials, and also but able to permeate constantly with the longer time. So we hope that this is the conclusion. By looking into our natural surroundings and by reusing some of the discarded natural resources, several functional biomaterials can be easily identified and implemented for promising wound healing application with a reduced impact on the environment. I would like to thank my PhD student, Dr. Nur Hazwani, my students, Muhammad Khairul Hafiz, Sarah Amalina, Associate Dr. Nadia, Dr. Jama, Rosliza, Dr. Fatilah, and my Sifu, Dr. Professor Chang Seo Park from South Korea. So with that, thank you very much.
Thank you very much, Dr. Rosani, for the interesting sharing of your research work. Okay. So all questions by the participant we will arise during the forum. Okay, you please feel free to write any of your question in the chat box. Thank you again, Dr. Rosani, for your kind sharing. Okay, let's just continue with the third speaker for our today's afternoon session. I invite Associate Professor Dr. Laura Navika Yamani. Okay, you're welcome to share your slide, your PPT slide.
Yeah.
Okay. Hello, Dr. Laura. Are you
Hello,
here?
hello. Okay, I share my slide
Okay.
now.
All right. All right. While waiting for Dr. Laura to share her slide, let me introduce a little bit on Dr. Laura's background. Okay, Associate Professor Dr. Laura Nabika Yamani is currently professor is currently in the Division of Epidemiology, Department of Epidemiology, Biostatistics, Population Studies and Health Promotion Faculty of Public Health, Universitas Air, Langga. Okay, she has obtained her PhD in Kobe University Graduate School of Medicine, Kobe, Japan. Okay. Okay, I am now reading Dr. Laura CV because she provide with her long CV and I am extracting the important information from her CV. Okay, so a brief through to her career milestone. Previously from 2021 until present, she is the head of research center on global emerging and re-emerging infectious diseases, Institute of Tropical Disease, Universitas Air. And also, until now, she is also the coordinator of public relations in Faculty of Public Health. And also she has been a reviewer in several journals as well. And she has also published in many journals, in many index journals throughout her career. Okay, without further ado, I welcome you, Dr. Laura, to share your interesting presentation. You're most welcome.
Okay, thank you very much for Dr. Nur Isyan to introduce me. She is my mentor when I did research in UTM about 6 months.
Yes.
Nice to meet you again.
Yes, nice to meet
Yeah,
you.
if I'm not mistaken, maybe more than 10 years ago, yeah, we met
More than 10 years
in
ago. We are lab mates.
UTM.
Yeah, we are lab mates together.
Yeah, okay. Okay, I will start my presentation. Assalamualaikum warahmatullahi wabarakatuh. Very good afternoon, everyone. First of all, I would like to say thank you very much for the opportunity for having me today in this international symposium collaboration between Universiti Teknologi Malaysia and Universitas Air. For this time, I will share about our research experience using one technology that very important and powerful in recent time, that is ultra deep sequencing. This technology is sophisticated and useful, especially during pandemic COVID-19, because as we know that this tool can be used to detect the whole genome sequence to see the variation or mutation of genome viruses, for example, virus SARS-CoV-2. Therefore, we can know the correlation between genome viruses and a new characteristic of virus appearance when the virus make more dangerous, more easily transmitted, more progressive disease, and then we can look at the mutation happen or perhaps a new strain of the virus coming. Also, using this technology can have incredible purpose to find new pathogens which is not found previously. Therefore, we can know the diversity of pathogen in the world environment or host like a human and animal that we do not expect before. The analysis of a genome of pathogens finally can be useful for drug design, vaccine development, and also diagnostic development as a great effort to eliminate infectious disease. In this opportunity, we would like to share one kind of application using ultra deep sequencing, or we can call as next generation sequencing for detecting variants of hepatitis B viruses, which is spread especially in Indonesia. Before we show our analysis of variant detected by ultra deep sequencing for the background of the research, we study about the hepatitis B virus in Indonesia because in Indonesia, hepatitis B disease becomes still endemic with ranks middle to high prevalence depending on the area. For example, in the eastern of Indonesia, like Nusa Tenggara province, the prevalence of hepatitis B disease is quite high compared to the other area. In addition, the important the important reason to study about the hepatitis B virus because this virus also can cause cancer in the liver, or we call as hepatocellular carcinoma. As you can see in the map, here, some area in Indonesia, hepatocellular carcinoma cases is documented highly. Therefore, this disease may become a health problem until to date. If we talk about the hepatitis B virus, we should know about the structure of the virus. Hepatitis B virus genome has four kinds genes as described in the slide, including surface gene, polymerase genes, core genes, and X genes, and it has seven of open reading frame for producing the protein. One gene can have more than one open reading frame and produce more than one protein. As we can see in the table about the type of gene and the protein that can be produced. This protein have each function for virus survival in the host body infected. For example, it's PSAG as a antigen protein of the virus, which is responsible for binding to host cell receptor. Understanding of a virus genome is very important to see the occurrence of a mutation, which gene of the virus is mutated and how does the result happen. Some previous studies have reported that some mutation in HPV genome are correlated with the progression of liver disease. This finding is also interesting for us. So this slide explain us how the mechanism of HPV variation or mutation generated in the patient infected with the hepatitis B virus. Inside the body, HPV can produce the high number of virion per day through the replication process, generating around 10 to 11 with the possibility high mutation rates of one substitution or mutation in every 10 to 5 nucleotides. Furthermore, immune body will combat the emergence of a mutation after replication process and remain the stronger virus that can still survive and make the quasi-species pool in the host body. Quasi-species is a group of viruses related by a similar mutation or as a group of strain. Quasi-species is divided into three types: a major viral population, when the number of virus strain is dominant in the pool of a host body, intermediate in the middle number, and minor viral population when the virus strain appear in low number. Quasi-species is also not only influenced by immune selection, but also can be selected by drug exposure. To see the viral quasi-species pool in the host body infected, we can use ultra-deep sequencing or NGS. When compared to another technology, is used routinely before, like Sanger sequencing, NGS are capable to generate several gigabases of sequence in single experimental run. This means that with Sanger, sequencing, we may only only be able to find a major feral population. While using NGS, we can also detect in intermediate and a minor feral population of many strains that may exceed a million. Therefore, we can see the powerful detection of NGS here. NGS that we use in our study is Illumina sequencing technology. In the first step, we should prepare our sample DNA extracted from a blood sample or stool sample or saliva sample and etc. The DNA attached to the flow cell is then replicated to form small cluster of DNA with the same sequence. When sequenced, each cluster of DNA molecule will emit a signal that is strong enough to be detected by camera. The sequence generated can then be aligned to a reference sequence. This look for match or a change in the sequence DNA. In our study, we focus on detecting the mutation in major hydrophilic region of a hepatitis B virus. MHR is located in the HBsAg, which is one of the protein produced by surface gene. We know that MHR is a major target for viral neutralization by anti-hepatitis B surface antibodies. Mutation in the MHR cause amino acid chains that may alter the antigenicity of HBsAg, allowing the virus to escape from neutralizing anti-hepatitis B surface antibodies. There are several consequences due to the emergence of the mutation in the MHR. The first, evasion of vaccine-induced antibody, and the second, the failure of immunoglobulin prophylaxis therapy, and the third, diagnostic failure of commercial assays for HBsAg, and the last, impairment of HBsAg and virion secretion to extracellular. And the fourth point may occur that HBsAg particle accumulated in the hepatocyte and may induce the endoplasmic stress and promote inflammation, finally leading to more severe liver disease. All these consequences also help that the virus can still grow well in the host because can evade immunotherapy and cannot be detected by diagnostic tests. Based on the background, as we mentioned before, especially to prove there is correlation between the MHR mutation and progression of liver disease, the aim of the study is using NGS to detect the MHR variant in HPV quasi-species from Indonesian patients with different clinical liver disease stages. To conduct this research, we use to collect the sample and to the some methods. The blood sample were collected from 30 Indonesian HPV patient with different stage of disease. We have divided two groups of patients that are a chronic disease group and advanced liver disease group. Advanced liver disease group including cirrhosis and hepatocellular carcinoma. Then we need extract DNA using kit and continue to PCR process to amplify specifically in the MHR gene. The last step, we do the NGS sequencing and finally analysis of the data sequences resulted. In this study, we compare several clinical factors between two groups of HPV patients from the total 30 sample, including 11 from chronic hepatitis and 19 from advanced liver disease. The results show that both groups have significant difference in HBsAg titer. As we can see in the table, the result indicated that advanced liver disease patients have a lower titer than a chronic hepatitis. This finding may be related with the MHR mutation, which caused the inhibition of HPSAG to be secreted to extracellular. So that's why this titer detected is low. Our study targeted in MHR mutation using the ultra deep sequencing in both group, chronic group and advanced liver disease group. We analysis in 3 different types of quasi-species that are major, intermediate, and minor variants population. We classified into minor variants population when the number of variants is less than 5% from the total population, while the intermediate when the number of variants in rings more than 5% and lower than 20%. And major population if the appearance of the variants is more than 10-20% in the total of feral population. As we can see in the slide, advanced liver disease patients have more mutation in MHR for intermediate and a major population than chronic group and significantly different. From this finding, we suggest that the increased number of the MHR variants in intermediate and major population were probably associated with the disease progression. After we found the significant number increase of MHR mutation in both group, the next we have tried to see the type of mutation appear in all sample calculated as a major, intermediate, and minor variant population. For the first, we see the MHR variant in the major population, like in this slide, as we know that MHR region has alpha determinant, which is a very conserved gene because this gene has not many variation and some variation in this gene may related to the genotype of the virus. In the MHR region, divided into several domains, pre-alpha determinant, and post-alpha determinant. Particularly, we focus on the first and second loop inside the alpha determinant that are responsible to attach the receptor of cell host and antibodies. The results showed that the number and type of MHR variant in the first and the second loops in advanced liver disease patient is more detected than in chronic patient. Some mutation is related with the immune escape detected in both group, but advanced liver disease patient have more type of mutation. In addition, mutation related with the impairment of HPSAG and virion secretion were detected only in advanced liver disease patients. From this finding, we suggest that this variant may contribute to decrease HPSAG titer as our result before. Because this result is supported by the previous report showing that this mutation caused the HPSAG may be accumulated in the hepatocyte and induce reticulum endoplasmic stress and then promote inflammation and lead to more severe liver disease. For the intermediate population of MHR variant, interestingly, the most famous of immune escape variant, G14R or A, located in the second loop, was found slightly higher frequency in advanced liver disease patient than chronic. This result indicated that the emergence of G145R or A mutation should be considered and monitored in the patient with advanced liver disease undergoing hepatitis B immunoglobulin therapy due to its impact on the efficacy of immunotherapy. Even the emergence of a MHR variant in the minor population was not a significant difference between the chronic and advanced liver disease patient. We found some immune escape variant and stop codon in minor population. The emergence of the variants associated with the drug resistance and also immune escape in minor population can be considered for a successful treatment or a drug selection. For the discussion, the increased HPV quasi-species of MHR in a major and intermediate population, it means that the number of variants, at least 5% of the viral population may be involved in the progression of disease, liver disease, as a consequence of immune evasion or impaired HPSAG secretion.
Okay, sorry, Dr. Laura, you have... Oh,
For
okay, finish.
yeah,
Already.
for
Okay.
the conclusion, by ultra-deep sequencing, the true prevalence of immune escape variants in the HPV quasi-species can be useful to predict the efficacy of vaccine-induced immunity or immunotherapy in the future. Data from the ultra-deep sequencing can also help predict the success of drug selection. Okay, that's all my presentation. Thank you very much for your kind attention.
Thank you very much, Dr. Associate Professor Dr. Laura Navika Yamani, for your interesting sharing on your current research work. Okay, so any question from the floor, you may raise up your question in the chat box, and then we will pull it together during the forum session. Thank you again, Associate Professor Dr. Laura Navika. Okay, so without further ado, please welcome our next speaker, which is Dr. Abdul Fattah Abdul Samad, okay, from UTM. Okay, Dr. Abdul Fattah, you may start sharing your slide. While waiting for Dr. Abdul Fattah to set up his slide, let me introduce a little bit on Dr. Abdul Fattah's background. Okay, Dr. Abdul Fattah bin Abdul Samad is currently a senior lecturer at the Department of Biosciences, Universiti Teknologi Malaysia, Skudai, Johor, Malaysia. He has obtained his PhD degree in Universiti Kebangsaan Malaysia in 2018. And also his bachelor degree in Universiti Kebangsaan Malaysia. So he didn't did his master. He skipped his master degree from bachelor degree to straight away to PhD. Okay. So along the way, Dr. Abdul Fattah also has received several research grants, including national and universities grant, and also he has won several awards, which are bronze medal in 33rd International Invention, Innovation and Technology Exhibition, ITEX 2022, the latest one, and he has also won Anugerah Penyelidik Harapan in 2020. And also at the same time, silver medal in Industry, Art and Technology Exhibition INATEX in 2020 as well. So he has also received several teaching awards and also have published several publications in index and non-index journal. Okay, so without further ado, I please welcome Dr. Abdul Fattah to share your interesting work with all of us. Please welcome.
Yeah, thank you, Dr. Izian, for the nice introduction. Bismillahirrahmanirrahim. First of all, can you see my slide?
Yes, very clear.
Okay. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today I'm going to share a little bit on my work. And I'm Dr. Fatah, Senior Lecturer from Department of Biosciences. So my interest is on microRNA. So what is this molecule? So I will share about this molecule in this session. So in this session, I will provide to you the overview of microRNA in plant and human as well. Because microRNA is actually a gene regulator, which we can apply in genetic manipulation. So my topic today is microRNA, small molecule, huge impact. And I will share a little bit on my previous work and my upcoming work. Okay, first of all, what is microRNA? Actually, it's a type of RNA species. For those who are familiar with the molecular things, I think you are familiar with RNA. But for microRNA, it's another species of RNA molecule. It's a group under the small non-coding RNA, which the base compositions is about 20 base pair. So basically the function, it's involved in gene silencing at post-transcriptional level. So according to the public database, microRNA, we have a public database known as I-Bes. So according to this database, currently microRNA, the total number of microRNA is about 38,000. So these 38,000 of microRNA are derived from plant, animal, and human, and also virus. Because organisms like fungi or bacteria, they don't have this microRNA molecule. Only 3 organisms: plant, mammal include human and animal, and then virus. So as I mentioned earlier, microRNA is a group of small RNA. And what is small RNA? Actually, small RNA is defined as any RNA molecules that have nucleotide 200 base pair and below. So anything above 200 base pair, we will categorize it as large molecule of RNA. So when we zoom in into the small RNA group, we can see another small molecule of RNA like snow RNA. Snow RNA is a type of small RNA that involved in RNA modification. And then small interference RNA. Okay, for small interference RNA, or by short, it goes by siRNA. This molecule, the function is similar like microRNA, but the way how it's synthesized in the cell is different. And then next we have tRNA. tRNA, as we know, it's involved in translation from mRNA to become protein. That's where the tRNA will get involved. And finally, microRNA, which our topic today. And for your information, microRNA is represent the largest group in small RNA group. So involvement of microRNA in gene expression, how microRNA work inside the cell, regardless of any cells like plant or mammal cell. When we go back to the concept of gene expression, DNA will undergo 2 major processes before it can turn into protein. The processes are transcription and translation. DNA will be transcribed to become mRNA, and then the mRNA will be further translated to become protein. So at this stage, at the mRNA, the microRNA will regulate the gene. or known as post-transcriptional level, because after the transcription, post-transcriptional level. So a little bit on microRNA biogenesis. MicroRNA biogenesis means that it's the way how microRNA being synthesized inside the cell. So in this slide, I bring to you two different figures. The one, the left side, the green one, is the microRNA biogenesis from plant. Meanwhile, at the right side, the red one, is the one that from mammal cell. Actually, if you want to go step by step, it's quite details and have some difference between these two biogenesis way of microRNA. But in general, the step involve the transcription of microRNA gene. We have the DNA, and inside the DNA is located the microRNA gene. And after the microRNA being transcribed by RNA polymerase, it will form the primary microRNA. Primary microRNA is a long single-stranded RNA molecule. And then the machinery from the cell will process this primary microRNA to become precursor microRNA, PRE, represent precursor. And then the precursor microRNA will be further processed by the cell to become duplex microRNA. What we mean by duplex is a short double-stranded microRNA. After that, the duplex microRNA will be combined with a protein known as agoprotein to form RNA silencing complex. When the microRNA is in this state, it will ready to perform its function. We call it as mature microRNA. So the functions of microRNA, like I said before, it act at the post-transcriptional level where it will bind to mRNA. When it binds to mRNA, there are two possible mechanisms, either in plant or animal. The first one is by mRNA cleavage. When microRNA bind to the mRNA, the target, the microRNA will induce the cleavage of mRNA. That's the first mechanism. The second mechanism, the microRNA only bind to the mRNA, but it's not induce the cleavage. Only it prevent the ribosome from get access to the mRNA. So when ribosome cannot get access to the mRNA, no protein will be produced. So that's the two distinct mechanisms how microRNA work. So microRNA discovery approaches, how this microRNA molecule is being discovered. Long time before. What I mean is a couple of decades ago, first microRNA was discovered through forward genetic. Forward genetic is the first method that can detect the microRNA. Back in 1993, if I'm not mistaken. And then when the time goes, there are several approaches has been developed in order to improve the chance of microRNA discovery. Like homology search. Homology search is based on the computational approach. However, later on, you will need to validate it using the experimental approaches. And then cloning, the regular cloning, and the most advanced method so far is a deep sequencing, where in this approach, we can detect million copies of microRNAs at once. So using this approach, deep sequencing, here I bring to you my previous work, where I involved in the library preparation of microRNA library. If you can observe the gel here, I already put a mark on the gel. This part actually will be sliced and purified. After that, we will send for sequencing. So what is the importance of microRNA? So in plant, this microRNA is being very important in three major processes. The first one is plant development, and then stress response, followed by secondary metabolite regulation. So in plant development, microRNA regulate a number of processes just to ensure the proper growth of plant and development. The process included leaf morphogenesis, and then formation of roots, and also organ polarity. The MIR319, 396, all the numbers that you can observe, that you can look at this slide, actually represent for the types of microRNA. Then microRNA also involved in the stress response. For example, during drought condition in rice, this microRNA regulate many biological processes in order to ensure the plant survival. So many processes will get involved, like photosynthesis, respiration, or root morphogenesis. This type of processes is required by the plant to adapt in extreme environment. So microRNA play its role in order to make the plant able to survive. The next one is about the secondary metabolite regulation. Several studies showed that the involvement of microRNA in regulating secondary metabolite pathway. For those who not know about secondary metabolite in plant, actually we have three major groups. The first one is terpenoid, the second one flavonoid, followed by alkaloid. So among these three secondary metabolite pathways, terpenoid is the most diverse pathways, and the largest classes in secondary metabolite is the largest classes. So that's why I'm interested to get into the terpenoid pathway, how microRNA get involved in regulating this terpenoid pathway. So previously, we managed to identify a few microRNA that affect the biosynthesis of terpenoid. Terpenoid consists of two main pathways. The first is mevalonate pathway. The second one is non-mevalonate pathway. And we managed to identify which microRNA attack certain pathways. And interestingly, we get microRNA that regulate the key enzyme of that pathway. That will give us the idea to do some genetic manipulation in the future. So role of microRNA in human. In human, microRNA were reported to involve in various cellular processes and also diseases. So because the involvement of microRNA in this event, there are certain biotech companies want to develop a microRNA as therapeutic tools. As I mentioned, microRNA presence in human. So we can use this microRNA as therapeutic tools due to the mechanism to inhibit some genes. So in order to develop therapeutic microRNA, there are three ways. The first one, microRNA mimics, miRNA mimics. So the idea in microRNA mimic is we introduce the synthetic microRNA to the cell. Because when you get a disease, like cancer, certain microRNA will be downregulated. So the idea is we introduce the synthetic microRNA so we can restore the level of that downregulated microRNA. So when we restore the level of microRNA, supposedly the cell will go back to the normal state again. That's the idea of microRNA mimics. And then the second one, antisense microRNA. So about this antisense microRNA is opposite of microRNA mimics. We use the antisense microRNA to inhibit aberrant expression of certain microRNA. Because in certain condition of disease, the microRNA may not be downregulated. It's the opposite. It may be up or highly regulated. So we don't want that microRNA to be highly regulated because it will contribute to the disease. So that's why we come with an approach to silence the microRNA by using the antisense microRNA technology. And last but not least is artificial microRNA, where in this artificial microRNA is not actually the true microRNA as its name, it's artificial, where we combine microRNA and small interference RNA. Usually, we will use this approach in order to target very specific gene, because compared with microRNA mimics, artificial microRNA can produce much more specific target. So for your information, for each approaches, either microRNA mimics, antisense, or artificial microRNA, there are certain drugs that has been developed, like Mirna mimics, Mesomir-1. This is drug that synthesized based on microRNA. The microRNA involved is microRNA 16 in cancer cell. The idea is when in the cancer cell, the microRNA 16 level is low. So they want to restore the level of microRNA 16. The idea is by putting the synthetic microRNA 16. So then when the level of microRNA is being restored, the cell supposedly will go back to the normal. And for antisense microRNA, the examples here is miraversen, the drugs. This drug has been developed based on microRNA 122. Yeah, this miraversen, they inhibit the microRNA 122 because microRNA 122 is highly regulated in hepatitis patient. So they want to reduce this microRNA so the hepatitis can be cured. And the artificial microRNA has been used to treat Huntington disease. As I mentioned before, this artificial microRNA, it can attack very specific gene. That's why this platform, artificial microRNA, is being used to attack specific gene in Huntington diseases. Okay. Okay, this is my future project. I want to study, or I want to find a suitable microRNA therapeutic that can be used to cure kidney. As we know, chronic kidney disease, by now we still don't have any potential cure.
Sorry, Dr. Fatah, you have
Yeah.
3 more minutes.
Yeah, thank you.
Thank you.
This kidney disease still doesn't have an effective cure. Even with the drug, you can only slow the progress of the disease. So the only option we have now is not the only option. I will not say that. The alternative option we can have now is by developing microRNA, the therapeutic microRNA. So by using a specific approach, either microRNA mimics antisense microRNA or even artificial microRNA, perhaps we can achieve some achievement in order achieve some milestone in order to heal the chronic kidney disease. Okay, finally, conclusions and remarks. We can say that this microRNA play vital roles in gene regulatory network, and the key to understand the functions of microRNAs is to identify and validate the target genes. Because if we wrongly identify the target genes of microRNA, it will bring you to the cascade effect. False positive results. We don't want that to happen. That's why we need to run several analyses in order to validate the target genes. And finally, the complete understanding of their function will lead to the application in agriculture and medical sectors. I think, yeah, that's all from me. Thank you.
Okay, thank you very much, Dr. Abdul Fattah, for the nice sharing on small molecule but great impact the micro RNA. Okay, so later we will resume during this forum session for any question by the audience. Thank you again, Dr. Abdul Fattah. Okay, so let us continue with our second last speaker, which is Dr. Satya Chandra Wibawa Sakti, with the title Development of Polysaccharides-Based Magnetic Sorbent for Water Remediation. Okay, please welcome Dr. Satya. You may start sharing your presentation. Okay, I can see it clearly. Okay, so let me introduce a little bit on Dr. Satya Chandra. Okay, Dr. Satya Chandra Wibawa Sakti has received his Bachelor of Science in Chemistry program, Faculty of Mathematics and Natural Sciences, Yogyakarta State University, Indonesia, and later on pursue his Master of Science, Graduate Program of Chemistry, Faculty of Mathematics and Natural Sciences, in Universitas Gadjah Mada, Indonesia. And later on, he finished his PhD in 2015 from the Division of Environmental Science Development, Graduate School of Environmental Science, Hokkaido University, Japan. Okay, until now, since 2016 until now, he served as a lecturer at Department of Chemistry, Faculty of Science and Technology, Universitas Air Langga, and he is also the editor of Indonesian Journal of Chemistry, which is indexed in Scopus. Okay, so basically, his research interest is on environmental materials as well as environmental remediation. Okay, and he has also published in many index publication as well as book chapters throughout his career. Okay, so without further ado, I pass the microphone to you, Dr. Satya Sakti. You are most welcome. Okay, the floor is yours, Doctor. Doctor, sorry, I think we couldn't hear your voice. Are you muted? We still couldn't hear your voice, Doctor. Are you using your headset? Okay, maybe the technical team can assist Dr. Satya because we couldn't hear any voice from his side. Are you using your direct?
Can you hear me?
Okay, now we can hear you. Okay, please proceed.
Because I just turned it off and turned it on again. I'm sorry.
Yeah, okay, no problem. Sure.
Okay, sure. Okay, Assalamualaikum warahmatullahi wabarakatuh. Thank you, Dr. Nur Izan, for introducing me. Also, thanks to Universiti Teknologi Malaysia and Universitas Air Langga for the opportunity given to me. My research interest is actually development of magnetic absorbance. So for today's symposiums, I would like to share some of our works regarding on the development of polysaccharide-based magnetic sorbent for the water treatment. As we already know that water is an essential component of life and is consumed by almost creatures on the Earth's surface. It's also crucial since more than 70% of fresh water is vital for agriculture and other purposes. So access to the clean water is necessary for all its form. However, it's contaminated in various ways. So consumption of the polluted water leads to the several diseases. The water pollutant disrupt the ecosystem by causing damage. These pollutants are further classified into several categories. First is infectious agents, organic chemical, inorganic chemicals, radioactive substances, and eroded sediments. Numerous technologies have been developed to deal with the water pollution. This method can be classified into three main methods, namely electrochemical methods, physicochemical methods, and the advanced method. Each category consists of several conventional methods. For example, physicochemical method consists of precipitation, conventional precipitations, membrane, ion exchange, and absorptions. Each has advantages in terms of its simplicity or high efficiency or cost effectiveness. However, absorption probably is the most widely applied method. However, it has a significant problem, especially the occurrence of the secondary pollution due to the non-recollected absorbent after the absorption process. This will be more serious if the absorbent is the result of this synthesis by using the hazardous chemicals or material that not environmentally friendly. Therefore, it's essential to develop environmentally friendly absorbent and easy to recover to prohibit the secondary pollution happens. By using magnetic material as a quickly recovered absorbent have been widely developed. So in general, spinel ferrite is used as the magnetic core. Chemically, the ferrite itself consists of the trivalent and divalent metal ions that evenly distribute in octahedral and tetrahedral configurations. Due to its strong magnetic properties, spinel ferrite can be easily collected by using an external magnet and regenerated for subsequent absorption. Maybe the preparation is a little bit expensive compared to the natural absorbents like a clay, activated carbon, and so on. However, if we consider the high recovery of ferrite spinel, then this material is one of the most cost-effective material. However, it still have a problem. The problem is that the ferrite spinel surface tend to be unreactive to some type of pollutants. This problem can be overcome by inserting magnetic material into a stable polysaccharide structure. Besides being environmentally friendly, polysaccharides generally have many active groups that can act as absorbent site. Based on their charge, these polysaccharides can be classified into neutral, cationic, and anionic. Several polysaccharides are widely used as an absorbent, including starch, and then cellulose, dextran, chitin, chitosan, carrageenan, alginate, and gum. Polysaccharide-based magnetic sorbent synthesis method vary from the conventional co-precipitation. You can see in the picture, the conventional co-precipitation, one-pot synthesis, simpler method, and then the advanced one is the ultrasonicated assisted emulsion to make sure it has the smaller size and higher surface area. If we do literature survey, the research related to the application of magnetic polysaccharide as absorbent is increasing yearly. So in 2021, around more than 315 reports were published. Report here, it's mean that include the article, patents, and other Scopus indexed report. This data is actually the result of analysis data provided by Scopus. You can access in the Scopus website. So on this symposium, I would like to share some of what we have do in our laboratory relating to development of the environmentally friendly polysaccharide-based magnetic absorbent. And then the first is the detoxification of the chromium hexavalent and dipolluted water by chitosan-based magnetic sorbent. Chitin and chitosan probably is well-known biopolymers. It can be isolated from the shell of the marine animals such as crabs, shrimp, lobsters. This kind of the marine products we can find easily in our countries, Indonesia and Malaysia. Both materials can be synthesized by acetylation and deacetylation process, and both of the material are biodegradable, non-toxic, and easy to be synthesized. In our laboratory, we try to combine the magnetic, the ferric spinel with the chitosan by using a simple one-pot method. We react chitosan with iron salts and precipitate it by using sodium hydroxide to produce the chitosan-based magnetic sorbent materials. Then we further modified the magnetic chitosan using pyridinium to produce pyridinium type of magnetic chitosan, which have permanent positive charge on its surface. This positive charge have a good performance on the absorbing anionic type of pollutants, such as like hexavalent chromium and anionic types of dyes. Pyridinium magnetic chitosan can absorb hexavalent chromium in the water without being affected by the pH of the water or type of hexavalent chromium species. Means that you just put that material, chitosan-based magnetic material, and then shake it, and then within 10 minutes or 15 minutes, it can remove all the chromium hexavalent, no matter what is the pH on the water or the type of species of the chromium, it easily can be removed. Then we can also remove the absorbent quickly by applying external magnet. Then unrecollected of the absorbent can be prohibited. This means that secondary pollution can be prohibited. We also try to modify the magnetic chitosan or chitosan-based magnetic absorbent by using the DNA from the salmon milk. So this salmon milk actually is the fisheries byproducts in the Japanese island of Hokkaido. And we got a sample from our college in Hokkaido University. From that salmon meat, when we can extract the DNA and then split the DNA into the single-stranded DNA. Each type of DNA, double-stranded or single-stranded, then we bind on the surface of the magnetic chitosan, because due to the high phosphate contents of the DNA, it has ability to interact with some cationic pollutant in the water. The experimental results show that double-stranded DNA modified magnetic chitosan adopt slightly different mechanism with the single-stranded DNA. In the double-stranded DNA, the anionic the cationic type of dyes. It's bound by the intercalation and electrostatic interaction. So both mechanisms happen in the same time in the surface of the double-stranded DNA. But the intercalation mechanism, we cannot find it in the surface of the single-stranded DNA. Next, we also try to prepare the materials that can be used for the handling oil spill on the water surface. So in addition to heavy metal and dyes pollution, we also manufacture polysaccharide-based magnetic sorbent for handling of oil spill on the water surface. Since oil is occur in the surface of the water, so we have to prepare absorbent that can be float stably. So in here, we try to synthesize the alginate type. That we know that oil spill even oil spill that happens occur either intentionally or result of this disaster. The oil spill event due to the Gulf War probably is the largest oil spill event in the history. About 1.4 million tons of cracked oil were spilled on the purpose. You can also read the news about oil spill in various news, magazine, newspaper. Some even have made film based on that true story. Well, to be honest, before I designed that absorbent, actually I watched the Deepwater Horizon starring by Mark Wahlberg and Kate Hudson in 2016 to get the soul and then how to get that my material can be adopted on the real situation. So I watched that movie as well. Several methods have been developed to prevent the spread of the oil spill on the sea surface, including like the application of the boom, skimmers, or in situ burning, and application of dispersion. In situ burning can remove the oil on the surface of water quickly. However, it's produced toxic gases, and the dispersion itself will remove quickly also from the sea surface. But eventually, the oil will be moved from the surface to the seabed. Then finally, it will accumulate it on the seabed and contaminate it. If we can see in here, the absorbent itself are only used in the area around the coast. This is because the commercial absorbent tend to sink, so they are not effective for absorption of oil on the water surface. Therefore, we try to develop environmentally friendly floating absorbent. And then we use the alginate extracted from the sargassum, and then for the iron core, we use the iron sand that can be found near the coast area. Maybe this is the alginate extraction methods for the sargassum. I think this is very common method. And then for the magnetite, we extract the magnetite from the iron sand. The iron sand itself is obtained from the southern coast of Yogyakarta province. It's actually near my hometown. So like 20 kilos from my parents' house, you can find easily the iron sand. This schematic figure describes how we develop the floating alginate-based magnetic sorbent. We use the calcium carbonate as internal pore-forming materials and insert graphene oxide to improve performance in oil removal. So you can see the same image. There are the very large internal cavity. That internal cavity make the material, the alginate-based absorbent, is very light that can be float easily and then stably in the surface of the water. This is a schematic figure of how the oil spill be collected by using this type of absorbent. We try also the using seawater and then one drop of oil. That one drop of oil then surrounded by our material. Then we can move it to the edge by using the external magnet easily. It's attracted by magnet to the present of the magnetic core. This is another type of our material. And then we try to, the experimental data show that absorbent produce float stably. You can see in the figure here. And then show the good absorption performance on the crude oil, olive oil, vegetable oil, various type of oil we try. And then we can use it until 20 cycle, means that we can use for absorption and desorption up to 20 cycle. So it's very, in the economic perspective, it's very cost effective. Regeneration also is very easy. We try to using like a solvent like hexane, or we try to using sonication assisted desorptions. Then we can generate that material, separated the oil and the absorbent. Then we can use that absorbent for the next cycle until up to 20 cycle. In our research, we got support from the research partner in Malaysia, Thailand, Taiwan, and Japan. Now with Hokkaido University and Hokkaido Research Organization, we focus on the water and wastewater sampling and analysis. With Nagasaki University, now we try to optimize and how to scale up on the productions of the absorbents. And then with the National Sut Yat-sen University, Taiwan, we try to develop carbon-based absorbent, such graphene oxide, carbon nanotubes, fullerenes. Yeah, and then with the University of Malaya and Kasat University, now we're developing the photosensitive and conductive type of absorbent. We got the 1 grant for this research. And then with the UKM, University Kebangsaan Malaysia, we currently get a grant to fabricate or to isolate the magnetic nanocellulose from the various agriculture waste. We get sample from the plantation industry and the food industry in Indonesia. So, but unfortunately, I have no chance to do collaboration with the UTM researchers. The UTM is known as a strong research culture, so I hope that in the future I will also able to collaborate with the researcher from the UTM. Besides being published in scientific journal, our research results are also published as book chapters. Book are published in last year and this year. The first chapter that we published is entitled Polymer-Based Nanocomposite for Environmental Remediation, published by the Royal Society of Chemistry. The next is entitled The Magnetic Separation of the Pollutants for Environmental Remediation, published by Springer. Actually, all of this actually result of the hard work of my students. So not only my work, but also it's supported by the students. So they always try to show their best performance to support our research. So I also thanks to my mentors, my heads of the research group, also the department heads, Dr. Zaki Fahmi, for his continued support and guidance. Dr. Izan, maybe all from me. So thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you very much, Dr. Satya, for the very punctual presentation. Okay, so please, any question, we will make it into discussion during the forum session. Thank you again, Dr. Sakti. Okay, so without further ado, let us continue with our last speaker for today's session, which is Dr. Cheng Kian Kai, with the title Anti-Inflammatory Activity of Momodica carantia in RAW 2647 cells. Okay, so we before Dr. Cheng proceed with his presentation, let me introduce a little bit on his background. Dr. Cheng Kian Kai received the bachelor degree and master degrees in bioprocess engineering from Universiti Teknologi Malaysia in 2002 and 2005 respectively, and later on pursued his PhD degree in biochemistry from the University of Cambridge in 2010. And then from 2011 until 2013, he was a postdoctoral researcher with the Institute of Advanced Biosciences, Keio University, Japan. He is currently a senior lecturer with Universiti Teknologi Malaysia. From June 2019 until May 2022, he was the director of the Innovation Center in Agritechnology, Universiti Teknologi Malaysia, Paguh campus. His research interests include therapeutic effect of plants, metabolomics, system biology, and multivariate data analysis. So without wasting any time, I pass the microphone up to you, Dr. Cheng. You're almost welcome.
Thanks a lot, Dr. Isian. Can you hear me? Dr. Isian, can you hear me?
Yes, yes.
Okay, thank you, thank you. Yeah, thanks a lot for the introductions. So, and first of all, I'd like to thank the organizer for giving me this opportunity to share my research with my friends in UTM as well as from Indonesia. So my name is Chang, and today I will share with you a topic that has been we have been working on in the UTM Bago here on the anti-inflammatory activity of monomolecular Chalantia in raw 264.7 cells. So as you know, so basically monomolecular Chalantia is a tropical climber that is widely cultivated in Asia, in Malaysia, I believe in Indonesia as well. So it is known, also known as the bitter gourd, bitter melon, karela, and also like perikata, for example, in Malay language. So basically in Asia, it is mainly consumed as food or as folk medicines. So it is best known for its anti-diabetic activity, particularly due to carotene, so which is one of its bioactives in the monomolecular Chalantia. So it is actually a combinations, equimolar combinations between the stigma sterol glucoside and also cytosterol glucoside. And a lot of research has been published supporting its role as the anti-diabetic compound in bitter melon. So there are also a number of studies showing that monomolecular Chalantia actually also has anti-inflammatory activity. So there are some research published working on the in vitro models and also in vivo studies as well. So it is just that the underlying anti-inflammatory mechanism of monomolecular Chalantia is still not yet established. So that is why our lab has been working on this for the past few years. So I would like to give a bit introductions about inflammation. So basically, inflammation is an immune response of a biological system towards harmful stimuli. So chronic inflammation has been associated with many diseases actually, so including cancer, cardiovascular disease, metabolic diseases, diabetes, and many others. So when we talk about inflammations, so we have to introduce like a macrophages, which plays a crucial role in regulating the inflammatory events and also immune responses in biological system. So in laboratory, macrophage has been used as a cell model of inflammation study. So in which the macrophage can be activated. What I mean is that can be induced by treatment with lipopolysaccharides or LPS for short. So LPS is like a compound from the outer surface of some of the gram-negative bacteria, which will trigger inflammations in the macrophages. So in our study, we use the raw 264.7 murine macrophages as our model, and then we activate it by using the LPS, and then we want to study what is the effect of LPS on these macrophages and what monomolecular Chalantia can do in terms of suppressing the inflammatory event in these macrophages. So some of in our experiment, so we show that when the macrophage is treated with LPS, as you can see for in the a second column for each of this a subfigure here. So the pro-inflammatory genes expressions, including IL-6, TNF-alpha, IL-1 beta, COX-2, IL-X, they are all being significantly upregulated when the cells are treated with LPS. That means it also supports that the cells are having inflammatory event following treatment by LPS. So, but when we treat the cells with LPS together with monomolecular Chalantia, so we can see from this graph here, So the gene expressions for all these pro-inflammatory genes are significantly reduced, some up to 84%, some up to 95%. So, and some like a minus 28%, for example. So this data show us that Momalika Sharantia can suppress the inflammatory event induced by LPS in the raw 264.7 macrophages. So we further study this like a model by assessing what happens to the NF-kappa B nuclear translocations in these cells. So NF-kappa B is one of the compounds which is very important. It plays a key role in the inflammatory events in the cells. So we use confocal like a microscope to study what happens to the translocations of this NF-kappa B. So in the diagrams being shown here, so the blue DAPI dye shows the nucleus. So which shows on the left column here. The one in the middle shows the green dye, which represent the NF-kappa B. So, and then the columns on the the third column here, so shows the combinations between the first column and also the second column. So what happened is that when we have a control cells in which we didn't treat with any of those compounds like LPS or Momalika Sharantia, so basically all the NF-kappa B are accumulated in the cytoplasm. So that is why you see in the middle of the cells, so the intensity of the green dye is actually rather low. So when we treat the cells with LPS, the cell is activated and then it starts the pro-inflammatory event. So right here, you can see that the whole cells is color in green. So in which it means that the NF-kappa B already translocated into the nucleus. And then once it is in the nucleus, it will trigger the inflammatory event. So once we co-treated the cells with LPS and also Momalika Sharantia, so the cells looks much more similar to the control cells. So it means that this Momalika Sharantia can actually prevent the translocations of the NF-kappa B from cytoplasm into the nucleus, and then this can be like correlated with the results in my previous slides, in which the expressions of many pro-inflammatory genes, including IL-6, TNF-alpha, and many others, are actually being suppressed when we treat the cells with Momalika Sharantia. So although the result shows us the anti-inflammatory ability of a molecule Sharantia, it tells us nothing about the mechanism. So that is why we further our study by using metabolomics analysis to investigate the perturbations in cellular metabolism associated with the inflammations and also the molecule Sharantia treatment. So in this case, we are using like a proton NMR spectroscopy to investigate the changes in cellular metabolism. So once we have the metabolomics data, we process the data by using PCA and also PLSDA multivariate data analysis. So in this diagram here, so the black dot shows the control. The red one shows the one that treated with a Momalika Sharantia, and then the blue one represents the one treated with LPS, in which it is associated with the inflammations, and then the green one shows us the samples in which co-treated with LPS and also Momalika Sharantia. From this PRSDA component diagram scores plots here, so we can see that actually the group for the LPS treated cells can be well separated from the controls. So that means these groups of like blue dots here, they may have different metabolic profile as compared to the controls. But when we treat the cells to get with the Momonica Shantia or co-treated with LPS and Momonica Shantia, so they are actually very similar to each other. The group B and also group D, which is in red and also in green, they are grouped together. So which means that the Momonica Shantia can actually normalize some of the like metabolic perturbations induced by the LPS treatment. So this is what happens, an overview of the metabolic profiles in intracellular metabolomes. So when we look into what happens in the cell medium, so basically we see very clear separations within two cluster here. So the one on the right hand side is the controls and also RPS, and the one on the left hand side is all cells treated with a molecular shantia. So that means when we analyze the metabolites in the extracellular medium, it is mainly affected by the MC treatment. So the effect of the RPS cannot be seen clearly from this diagram here. So when we look into each of these metabolites, so this heat map here shows us the relative metabolites concentrations in intracellular of the raw cells. So the blue color here shows that the concentrations of the metabolites is relatively low as compared to the one in red. So red means like high concentrations. So from this diagram here, we can also notice that the main metabolic perturbations is due to the MC treatment, in which we see the MC group and also the LPS plus MC group, they have rather different profiles from the controls and also LPS. But there are also some notable changes, such as like lactate, and also like some of the changes in the like glutamate, glutathione, alanine, for examples, and also pyruvate, and these are the metabolites and also the pathways being perturbed by the MC and also LPS as well. When we look into the like a metabolic profiles in the extracellular medium, so this case, so basically again, so it shows a clear separations between the cells either treated with MC or without MC. So again, there are some notable metabolic changes, including again is lactate here, so pyroglutamate and a few others which stands out as compared to the others. So what I want to focus here is the changes in glucose and also lactate. It shows that not only MC, the LPS also affect the metabolic concentrations in for glucose and also for lactate as well. So from this results here, we do some further analysis by studying the glucose consumptions and also lactate productions by the cells, and our result shows that LPS will increase the glucose consumptions. So that means when the cell is inflamed, it will consume more glucose. But when we treat the cells with LPS and MC, so basically there is not much difference between the LPS group and also LPS plus MC. So then if we focus on the right-hand side on the lactate productions, so LPS will increase the lactate productions, but the Momonica Sharantia or the beta-melon treatment actually reduce the lactate productions. So from here, it gives us an idea that so the inflammations can be related to like a glucose metabolism, which has been put into hypothesis in some of the previous study. So from here, so what we did is that we further our study to investigate the relative mRNA level of the gene expressions of a few glycolytic genes in the cells. We tested about 10 of the genes And then out of that 10 genes, so 3 genes actually stands out, in which the glucose transporter 1, which is important in transporting the glucose into the cell. The second one is hexokinase 2, which is the key enzymes in the glycolytic pathway, and also the LDHA, which is involved in the lactate productions. So from these results here, it shows that the LPS actually increase the gene expressions of the glucose transporter. So it can be correlated with the increased glucose consumption. But when the cells is treated with molecular Shantia, it is significantly, markedly reduced up to 94%. So it also gives us an idea that GLUT1 may play an important role in the inflammatory event. But what happens if, let's say, the cells is not treated with LPS? If, let's say, the cells is not inflamed, would MC still exert this kind of effect? So that is why after that, we carry out a further study focusing on the control and also the cells treated with MC. So what we observed is that for GLUT1, the glucose transporter, so actually the treatment with molecular Shantia will reduce the relative mRNA level for the glucose transporter, whether the cells is inflamed or not. But not much difference is observed for the hexokinase 2. So then it leads us to the together with the previous findings, it comes to our attention that the macrophages actually undergo reprogramming in their cellular metabolism during the inflammatory response, and in which the macrophage it preferentially metabolizes glucose. So very similar to cancer cells actually. So a manner what we call as the a Warburg effect. So the cells prefer to use glycolytic pathway to process the glucose instead of a TCA cycles. So when we look into the literature, actually there's a few study that is consistent with our data. So the first one is from the Firmament 2014, in which high glucose was found to induce the inflammatory response, and the overexpressed GLUT1 will trigger the pro-inflammatory response as well. And then basically, the Firmament also suggests that GLUT1 is actually mediated the inflammations in this raw 264.7 cells. So there are also some changes in which the MC also modulates the amino acid metabolism as well, in which this metabolism can be associated with the inflammatory event. So some significant changes include in serine, cystathionine, glutathione, glutamate as well. So the conclusions that we get from the result is that so basically the serine metabolism is known to support the LPS inductions of glutathione synthesis, and then it is actually required for the pro-inflammatory event. And also the intracellular accumulations of cystathionine also increase the release of glutamate in the extracellular medium, and high glutamate environment can also be linked to the inflammations as well. So we also found some interesting changes in the BCAA amino acid, the branched amino acids, the leucine, valine, isoleucine, GABA, and also uridine. These are all actually anti-inflammatory metabolites reported before. So when the cells are treated with a molecular Shantia, so the concentration of this anti-inflammatory metabolite actually increase inside the cells. So and then from Lee et al. To 2017, the BCAA was reported to exhibit anti-inflammatory effect. Okay, so there's a few mechanisms that is proposed by the current data, including perturbations in glucose metabolism, changes in the amino acid metabolisms, and also the concentrations of anti-inflammatory metabolite as well. So this is a summary of, yes,
Two more minutes.
sure, thank you. This is a summary of our study. So in which, as I mentioned, so the effect of MC can be summarized into these three: inhibits the upregulated glycolysis and perturb TCA cycles, modulate the amino acid metabolism, and also increase the cellular concentrations of the anti-inflammatory metabolites. So MC was found to inhibit GLUT1, the glucose transporter, hexokinase 2, the key enzymes in the glycolytic pathways. It inhibits the translocations of NF-kappa B into the nucleus, and then it inhibits the expressions of all these pro-inflammatory genes. So at the end, we also observe that it actually the lactate in the extracellular medium is significantly reduced. So for this work, I would like to thank Dr. Li Xian, who mainly worked on this project, and also Professor Jiang Dong from Xiamen University with his help on the NMR experiments, and also the Associate Professor Dr. Wong from University Malaya for her help in the gene expressions analysis. So that is mainly what I wish to share with you today. And then I'd like to thank you all for attention. Thank you.
Okay, thank you very much, Dr. Cheng Kian Kai, for the interesting sharing of your current research work. Okay, that marks the all 6 invited speakers for this afternoon session. All the 6 speakers, including the plenary speakers, has excellently delivered their respective speeches. Okay, now I open to the discussion session in the forum. Okay, so maybe all the speakers can get prepared or to answer the questions from the audience. I'm glad that it seems that for this afternoon session, it seems quite active participation from our audience. Okay, so while I'm scrolling down the chat box, okay, first question goes to Dr. Rosnani from Dr. Noor Hayati. Assalamualaikum, Doctor. Okay, she asked, okay, thank you for your nice presentation. And then Dr. Noor Hayati asked, what is your challenges while working with plant-based ingredients for wound care management?
Okay, thank you very much, Dr. Nayati and Madam Chairman. So, as we know that assessing a burn wound, the status of healing is currently an invasive process. So sometimes it needs biopsy and painful and scarring. So we, as a researcher, we try to use as minimum methods, for example, like in vitro, or we develop a non-invasive method to analyze the wound healing effects on animal or human. So because you know that sometimes if you claim cosmetics products, some countries are not allow the animal study. So but if the category is wound healing, so it's under the drugs, sometimes under the drugs regulation. So you need to do the in vivo study. But in our case, we try to do the non-invasive approach, such as we try to proceed with the skin diffusion method, using the in vitro skin diffusion method, using the non-invasive skin collection and analysis, or using the optical coherence. That is the challenges in wound healing study. Thank you.
Okay, thank you very much for the answer, Dr. Rosnani. I hope that answers the Dr. Noor Hayati's question. Okay, let's proceed further with the next question. Our moderator, Dr. Siti Zulaiha, has received a question from the audience, anonymous. Okay, and it goes to maybe, I think, Dr. Rosnani as well. How the Malaysian government policy reacts to the application of biomass in the healing management of the wound?
Okay, thank you very much. From the questions. So actually, it depends on your product claim. It depends on your product claim whether if the topical application if under the cosmetic application, under the National Pharmaceutical Regulatory Division, you need to follow the Annex 1 Part 8 cosmetic claims guideline. So I think for our Asian region, we are under Asian harmonization. So might be our guidelines is quite similar. So if we claim as medicinal patch or wound care products, so it's under the drug category. So if your product is under drug category, you need to follow from the preclinical study, clinical study. So, but if you just claim like, for example, antibacterial, so it can be under cosmetic. But if your claim is beyond that, so might be under the drug category. So that is my answer, Dr. Izian.
Okay, thank you. I just would like to add on. Is it possible for that product use two claims? One is for cosmetic and one is for drugs.
Sorry, if your product is under drug category, for sure you can claim under cosmetics. That is my opinion, because drug is much more higher claim, meaning that your products can be cleaning, can be used as wound cleaning, or can improve the scar treatment. So that is the higher claim. But cosmetic usually for antimicrobial also, you can only claim for antibacterial, if I'm not mistaken. But you can check under the Annex 1 Part 8 cosmetic claims guideline. You can view in the NPRA website for details.
Okay, so but it is depends on the claims that we are.
Yes.
Okay, the next question by Mr. Kamarul Arifin also goes to Dr. Rosnani.
Okay.
Any clinical trial needed for wound care purposes if using biomass? Clinical trial.
Okay. As I mentioned before, it depends on your claim also. So usually, I know that using biomass, you need to do the treatment, right? I think Dr. Azian also expert in biomass pre-treatment, right? We use a lot of chemicals to treat, to make sure that the color and the properties is acceptable. So you must make sure that you follow all the guidelines, meaning that the cytotoxicity is pass, meaning that how many percent of your ingredients can be applied on your topical application, and then is it toxic to the cell? If toxic to the cell, maybe you need to remove all the toxic materials, such as the residue of the chemicals, the compounds that might be harmful to your skin. So you can proceed also, but you must make sure that all these toxic ingredients in your biomass compound remove before you apply.
Okay, thank you very much again, Dr. Rosnani. Okay, so we proceed further with question to Assistant Professor Dr. Laura. Okay, from Mr. Kamarul, but maybe it is also from anonymous. We don't know who. Okay, what is the success rate of the drug selection? Have you had any collaboration with the pharmaceutical company or hospital?
Okay, thank you very much for the questions. I will try to answer. For our study, we have not seen yet the success rate of the drug selection, because we still focus on the surface genes, which is responsible to bind a receptor of host cell. We are looking for is there any relationship between the mutation in the surface gene and progression of disease, as I explained before in the presentation. But ongoing research, we also try to see the mutation in the polymerase genes using ultra deep sequencing. Polymerase genes is a gene target of a drug to block the replication process. However, detection of a mutation using ultra deep sequencing is quite expensive. Because of that, it has limitation about the data of drug resistant mutation using ultra deep sequencing. But our research, we have a collaboration with the hospital because in the hospital, they have some patient who failed to be treated by some medication. Therefore, we look at what's happened in the genome viruses collected from this patient, and we report the mutation data obtained to give a little advice. Detection of mutation using ultra deep sequencing is not implemented yet in the laboratory in hospital, just limited only for the research. But we hope that our research data can be useful for a drug decision in special cases of the patient. Thank you.
I see. Okay, hope that's answering very well question to Dr. Laura. Okay, and in the chat box, I can see that there is question goes to Dr. Abdul Fattah, but Dr. Abdul Fattah apologized us because he needs to leave us earlier due to personal things that he needs to catch up. Okay, so feel free to discuss also among the speakers. Okay, before that, I have one question to Prof Hatip. Okay, regarding it is interesting on the hydroxyapatite and also the bovine hydroxyapatite, which is going to natural sources. But is there? I just would like to ask: is there any issue regarding the use of nanomaterials towards the human insight and the analogy and biology?
Yeah, I think I agree with the moderator about the using the new material with nano size. So that in our research, that we have several steps. The first in how to develop the nano size of the biomaterial, and then we apply in the cell culture in vitro method, and then continue to the in vivo in animal. If there are any toxicity or another disadvantage for this biomaterial, of course, we should investigate again in culture or in vitro or in vivo in animal. But we have several data, and I think we already published in several journals, so that for nano size of the bovine hydroxyapatite, there are no toxicity, and for a long term using of the nano hydroxy apatite in a pellet or a bone filler, as a bone filler or as an implant, there are no show about the disadvantage effect. We check the radiographic assay, and the bone, there are compatible with uh, 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 host bone of host, so that there are need more deep research, but until now our data suggests there are no toxicity in vivo using long-term implant or bone filler.
I see. Okay, so far we can mention that it is safe to be used. Okay, because
Exactly.
no toxicity has been reported. Okay, thank you very much for your answer, Prof. Hatip. Okay, let's move on. I have a personal question to Dr. Laura, my friend, my long friend.
Yeah,
Okay, Dr.
still
Laura.
bestie.
Yeah, Dr. Laura.
Yes.
Regarding your ultra deep sequencing that you have applied towards the hepatitis virus, can it also be done towards the detection of multivariant of the COVID-19 virus as well?
Yeah, of course, because we know that using ultra deep sequencing, we can detect the whole genome of virus, whole genome sequence of the virus. So it's mean that if we want to see or look at the variants of the COVID-19, uh, I think okay, we can use that.
Okay, so it means that can also use a SIM technique for the detection of the multivariant of the COVID-19 virus, isn't it? But
Yeah.
but have you tried have you tried the techniques with the COVID-19 virus, Dr. Laura?
Yeah, of course, of
Okay.
course. In Universitas Air, we have the ultra deep sequencing in the we call the place is the Institute of Tropical Disease, and in there we have the one of the machine of the ultra deep sequencing, and during the pandemic COVID, we also collect the sample from the COVID-19 cases, and then we try to see the what kind of the variants from the patient selected. Not all patient, but we just select the patient. For example, we have the several standard which patient that sample we collect, and we analyze using the ultra deep sequencing, because the ultra deep sequencing is very expensive to analyze the mutation. So that's why we give like the standard the condition of the patient that we can analyze.
Okay, very interesting. Because previously I also watched you have been interviewed by several mass media, isn't it? Previously during the COVID pandemic, isn't it, Laura? I've watched one of the interview session regarding the pandemic, and it is very interesting in terms of your sharing. Okay, my next question goes to Dr. Satya. Okay, regarding very interesting on the polysaccharides based magnetic for the water remediation, because I am during my PhD degree I also embarked on the polysaccharide as well, biomass. Okay, so how far is the implementation of the polysaccharide based magnetics in the industry?
Okay, there is actually like maybe like a 2 months or 3 months ago, I invited by the one industry. They are interested to apply the magnetic polysaccharide, since they have also the polysaccharide as the byproduct for their plantation industry. Then invite us to like join together to develop some material for absorption for the result to absorb some material from the food products. But actually, until now, we still don't meet the result, the economic calculations, since sometimes for the industry it's a little bit too expensive to be scaled up. Then now it's become my homework, since I have to substitute the reactions or the preparation steps so they can adopt based on their economic calculation. But hopefully in the short time they will agree with my proposal.
Yeah, exactly. Because normally the industry they will ask regarding the economic analysis.
They
Okay.
always make us to please make it cheaper. Please make it cheaper. Sometimes it's difficult for the for us as scientists, right? Because we have
Yeah.
to ignore some parameter, something that we cannot accept that as a scientist. Yeah,
Okay.
yeah, that's
So
how it happens.
yeah, okay. It sounds promising for our future. application. Okay, maybe can you work towards the pilot scaling of that?
Yeah,
Dr. Satya.
hopefully.
For your current research, have you been you are working on the remediation of heavy metals in the wastewater, or what kind of remediation that you are still embarking on?
Now we've since now our university focus on the was that the handling of the COVID-19. So sometimes we have the issue on the wastewater that contain pharmaceutical antibiotic. You know that during the COVID-19 outbreak, the people like to consume like antibiotic or some pharmaceuticals. Then now we can find easily in the wastewater. So I have one project right now focused on the development of the nanocelluloses, magnetic nanocelluloses, for the remediation for the pharmaceutical polluted wastewater. So we do sampling like water around our university hospitals, and then some in the pharmaceutical. We also work with the pharmaceutical industry to collect some samples.
I see. Okay, very interesting. Okay, so because of the pandemic, so you are forced to study on the effect towards the antibiotic and so on.
Yeah, it's depend on the what happened in the society or environment. So we have to switch our research.
Yeah. But I am sure that the polysaccharide based magnetic can be also applied in any other industry as well, isn't it? Yeah, have a big future potential. Okay. According to my time, it is now 5 p.m. According to Malaysian time. So I need to pass my microphone to our moderator. So I pass it to Dr. Siti Zulaiha for the wrap up and the photo session. Thank you very much again to all the speakers. Thank you.
Thank you, Dr. Izian.
Thank you,
Thank you, Dr. Izian, for chairing the session. So for viewers, thank you very much we wish you that, thank you very much, Dr. Izian, for sharing the session. And on behalf of the local organizing committee, I would like to wish thank you to speakers and viewers for their valuable attention. So viewers, and now we would like to invite all the speakers and viewers to switch on the camera and use the I-Bes 2022 virtual background for the group photo session. So, cameraman of the day, please get ready. So please give your best smile on the camera. With a count 1, 2, 3. One more. 1, 2, 3. One more. 1, 2, 3. So, ladies and gentlemen, see you again after tomorrow in the session on energy security at 9 a.m. Malaysian time. Thank you and have a very good day. Thank you. Bye bye.
Thank you so much. Bye.
Thank you, Dr. Zulaiha.
Okay, see you.
See you.